unusual topping requests before we build a pizza. And the following example defines two lists. The first is a list of available toppings at the pizzeria, and the second is the list of toppings that the user has requested. And this time, each item in request toppings is checked against the list of available toppings before it's added to the pizza. So the code will look like this. Available toppings is a list created, and request toppings is another list which created for the request toppings from the customer. Then we will write a for loop. Then for each request topping in the request toppings, we will check if this request topping in this available toppings list. So if this test gets true, then we print add this request topping. Otherwise, if this request topping item is not in available toppings list, then we will run another message. We ask customer, say, sorry, we don't have these toppings. So we create two lists. One is available toppings and one is request toppings. Then we write a for loop for each request toppings. Then test if this one is in available toppings. If it is true, then we print this message. If it is not true, then we run the else statement. So you can see the mushroom is in available topping list. So we're adding mushrooms. The same for the extra cheese, but for the French fries in the request topping, the message, sorry, we don't have French fries, will be run out. A dictionary in Python is a collection of key-value pairs. So each key is connected to a value, and you can use a key to access the value associated with that key. A key's value can be a number, a string, a list, or even another dictionary. In fact, you can use any object that you can create in Python as a value in a dictionary. In Python, a dictionary is wrapped in braces with a series of key-value pairs inside the braces. So this is a dictionary with two key-value pairs, and the key is color and points, and the value is green and 5. Accessing values in a dictionary. To get the value associated with a key, give the name of the dictionary and then place the key inside a set of square brackets as shown here. So we can access the value of key color. So this will print out the value of color. And similarly, this will print out the value of points in this dictionary. So this is the dictionary with two key-value pairs. So we can get the points value of this dictionary and assign to new points. Next, we can print out these new points with a message. So alien 0 is a dictionary with two key-value pairs. And we can print out the value of this dictionary's color. Its color is green. And we can print out the value of points. Points is 5. We can create this dictionary again. And we can get out the value of points and assign to this variable called new points. Then we can print out a message using these new points. So you just earned 5 points. So you can add new key-value pairs to a dictionary. To add a new key-value pairs, you would give the name of the dictionary followed by the new key in square brackets along with the new value. So let's add 2 new pieces of information to the alien 0 dictionary. The alien's x and y coordinates. So this is the original dictionary has 2 key-value pairs. Then we can add a new key-value pair called x position equals 0 and y position equals 25. So this is the dictionary with 2 key value pairs. And print out this dictionary, 2 key value pairs. Then we add another 2 key value pairs. And we print out again. Now the dictionary has 4 key value pairs, color, points, x position and y position, and their values. Notice that the order of the key value pairs does not match the order in which we added them. So Python doesn't care about the order in which you store each key value pairs in a dictionary. It cares only about the connection between each key and its value. And you can start with an empty dictionary. It's sometimes convenient or even necessary to start with an empty dictionary and then add each new item to it. To start filling an empty dictionary, you can define a dictionary with an empty set of braces and then add each key value pairs on its own line. So we can start with an empty dictionary with 2 braces. Then we add 1 key value pairs using alien 0, brackets color equals green, and points equals 5. So add these 2 key value pairs into this dictionary. We start with an empty dictionary. Then we add these 2 key value pairs into a dictionary. Then print out again. Now the dictionary has 2 key value pairs. Can modify values in a dictionary. To modify a value in a dictionary, give the name of the dictionary with the key in square brackets and then the new value you want associated with that key. So for example, consider an alien that changes from green to yellow as a game process progress. So we create a dictionary with only 1 key value pair, color is green. Then we can modify the value of this key color to yellow. So we create first key value pair green in this dictionary, and we print out the alien's color. The alien is green now. Then we modify the color to yellow in this dictionary. And we can print out again. The alien is now yellow now. And you can set dictionary with, for example, 4 x position, y position, and a speed medium. Can print original position for this alien x position. So position is 0 now, original. Then we can move the alien to the right. So if alien 0 speed is slow, x increment is 1. And else if speed is medium, then increment to 2, and else increment to 3. So because x speed is medium now, so the increment is 2. And we can also we can run this test first. So x increment will be assigned with a true value now. Then we can modify the position x position with current position plus x increment. So we run this to modify the value of x position. So print new x position. Now we'll see new position 2 because have increment with true value to the x position. And we can also remove key value pairs. So when you no longer need a piece of information that is stored in a dictionary, you can use the del statement to completely remove a key value pair. All del needs is the name of the dictionary and the key that you want to remove. For example, let's remove the key points from the alien0 dictionary along with its value. So this is a dictionary with 2 key value pairs. Then we can remove the points, the key value pairs with the points. Use del alien0 points in brackets. So we can create these key value pairs dictionary first. 2 key, so print. So there are 2 key value pairs in this dictionary. Then we remove 1 key value pairs. Points has been removed. We show again this dictionary now has only color key value pair. Because a dictionary can contain large amounts of data, Python lets you loop through a dictionary. You can loop through all of a dictionary's key value pairs, through its keys, or through its values. So looping through all key value pairs, to do so, you could loop through the dictionary using a for loop to write a for loop for a dictionary. So let's consider a new dictionary designed to store information about a user on a website. The following dictionary will store one person's username, first name, and last name. So this is a dictionary called user, and will store username Fermi, first name Enrico, and last name Fermi. Then we can write a for loop for key value in user this dictionary's items attribute. So this username items attribute will return the key value pairs. Then for each key value pair, we will print key its value and value its value. So you create names for the 2 variables such will hold the key and the value in each key value pair. You can choose any names you want for these 2 variables. So you can choose any name for these 2 variables. The second half of the for statement includes the name of the dictionary followed by the method items, which returns a list of key value pairs. The for loop then stores each of these pairs in the 2 variables provided. So we can create dictionary for the user. Then we can write a for loop, and in the user zeros items, then we print out this information. So all the key value pairs in this dictionary are printed out. The username, value, first name, value, last name, value. Another example of looping through all key value pairs. So we look at a dictionary of a favorite programming language of a number of people. So favorite language is a dictionary. Then the key is people's name, and the value are favorite languages of those people. Then we can write for loop. We'll create 2 variables called name, language, for name, language in these dictionaries items. Then we can print names, title form, concatenate with a message, and then concatenate with languages, title form. So favorite language is a dictionary. Then a for loop will print out information for each person's favorite language. So Yan's favorite language is Python, Sarah's favorite language is C, and so on. So looping through all the keys in a dictionary. So you can use the keys method. It's useful when you don't need to work with all of the values in a dictionary. So let's loop through the favorite language dictionary and print the names of everyone who took the poll. So this is the same dictionary as before. Then we can write also for name, create 1 variable called name in this dictionary's keys attribute. So then can print out each name's title form. So this is a dictionary. then a for loop in dictionaries keys attribute. Then only the keys and the people's name are printed out. So looping through the keys is actually the default behavior when looping through a dictionary. So the following two codes would have exactly the same meaning. We can write for name in favorite languages. Do not add any methods after this dictionary. Or we can write for name in favorite languages dot keys. These two statements will get the same result. You can choose to use the keys method explicitly if it makes your code easier to read, or you can omit it if you wish. And you can access the value associated with each key you care about inside the loop by using the current keys. So let's print a message to a couple of friends about the languages they choose. So we will loop through the names in a dictionary as we did previously, but when a name matches one of our friends, we will display a message about their favorite language. So this is the code. So we create same dictionary as before. Then we have friends, a list, two people of our friends. Then write a large for loop for name in favorite language to keys. So this name represents each name in this dictionary. Then print this name's title form first. Next, we write an if conditional test. So if this name in friends is this list. So if one of these keys is in this list, then we will print another message, hi, the name's title form, and a message, I see your favorite language is your favorite language's value, which language is title form. So we show this. Create this dictionary first. Then we create another list called friends with two items. Next, write a for loop to print out each people in the favorite languages list first. Then, if this person matches in this list, then we'll print another message for this friend. So first Yang print out, then Sarah print out. Because Sarah is in the friend list, then Sarah will have another message printed out. Then Edward print out. Then Phil, because Phil also in the friend list, then Phil will also have another message printed out. And you can also use the keys method to find out if a particular person was polled. So this time, let's find out if Erin took the poll. Same dictionary we produce. Then if Erin not in favorite language keys, we use not in. So favorite language.keys will return a list of these keys in the dictionary. Erin if not in, so print Erin, please take your poll. And the keys method isn't just for looping, it actually returns a list of all keys, and the line simply checks if Erin is in this list. Because she is not, a message is printed inviting her to take the poll. We can create this dictionary first. Then check if Erin not in this dictionary's keys list, will print a message. Because Erin is not in, so the message is printed out. You can also loop through a dictionary's keys in order. So one way to return items in a certain order is to sort the keys as they are returned in the for loop. You can use the sorted function to get a copy of the keys in order. So create this list. Then we use naming sorted favorite languages keys, then print out. Then choose this one, then create this first dictionary, then use a sorted this list first before we choose each item in this list. Then print message for the name, title, thank you. You can see. So now the names are sorted in alphabetical order. And looping through all values in dictionary. If you are primarily interested in the values that the dictionary contains, you can use values method to return a list of values without any keys. For example, say we can loop and print out programming language pool without the name of the person who choose each language. So this is the same dictionary. Then we can print a message following language has been mentioned. Then write a for loop. In this time, we use the values method for this dictionary, and then for language, the values method will get all values parts in the dictionary. Then we print out these old languages title for. So create this list, the dictionary first, then print a message. Then we use a for loop to print out all languages in this list. Sometimes you want to store a set of dictionaries in a list or a list of items as a value in a dictionary. This is called nesting. You can nest a set of dictionaries inside a list of items inside a dictionary, or even a dictionary inside another dictionary. So first, look at a list of dictionaries. In the last lecture, the Alien Zero dictionary contains a variety of information about one alien, but it has no room to store information about a second alien, so much less a screen full of aliens. How can you manage a fleet of aliens? One way is to make a list of aliens in which each alien is a dictionary of information about that alien. For example, the following code builds a list of 3 aliens. So we create 3 aliens with different information, for example, different colors. Then we can store these 3 aliens in a list called aliens. Then next, we can write a for loop for alien in aliens, print out each alien. Actually, each alien is a dictionary's information with key value pairs. A more realistic example will involve more than 3 aliens with code that automatically generates each alien. So in the following example, we also can use range to create a fleet of 30 aliens. So we can start with an empty list. Then next, use a for loop in the range from 0 to 30. For each alien number, we create each alien, new alien. Then append this new alien in the aliens list. Actually, each alien's information is the same. So next, we can show the first 5 aliens in this alien list. Print out. We should create 3 aliens first. Each one a dictionary. Then we can put these 3 aliens in a list. Then next, using a for loop for alien in aliens, print out each alien. So each alien is a list printed out. The next, we make an empty list first. Then we create 30 aliens and put them in this list. Then we can print out the first 5 aliens in this aliens list. Actually have the same values, key value pairs for these 5. And we can also print the length of aliens, how many aliens in this list. So the total number of aliens is 30. So these aliens all have the same characteristics, but Python considers each one a separate object, which allows us to modify each alien individually. So imagine that one aspect of a game has some aliens changing color and moving faster as the game progresses. For example, to change the first 3 aliens to yellow, medium speed aliens worth 10 points each. We can do this. We write a for loop for the first 3 alien in this list. Then the if test, if alien's color is green, then we change it to yellow and change the speed to medium and change the alien's point to 10. So we can set alien's color speed points to this value if alien's color is green in the first 3 aliens. So next, let's look at a list in a dictionary situation. So it is sometimes useful to put a list inside a dictionary. For example, consider how you might describe a pizza that someone is ordering. If you were to use only a list, all you could really store is a list of the pizza's toppings. So with a dictionary, a list of toppings can be just one aspect of the pizza you are describing. So in the following example, 2 kinds of information are stored for each pizza: a type of crust and a list of toppings. So the list of toppings is a value associated with the key toppings. To use the items in the list, we give the name of the dictionary and the key toppings as we would any value in the dictionary. Instead of returning a single value, we get a list of toppings. So we make a pizza dictionary. Then inside this dictionary has 2 keys called crust and toppings. So for the crust, there only one value is 6, but for the toppings is a list of values. Next, we can print out information. You order the pizza's crust. You put this type of pizza with the following toppings. Then inside the toppings, print each topping. So we create a dictionary, pizza, and with 2 keys, especially for the toppings, the keys is a list. Then we can print out information. You order the pizza. Which kind of pizza? The crust, thick pizza. You order the thick crust pizza with the following toppings. Then a loop for topping in pizza toppings. So pizza toppings will get this list because this list is the value of the key toppings. Then this is a list of with 2 elements. Then a for loop for topping in this list can print out each topping. So each topping are printed out. You can nest a list inside a dictionary anytime you want more than one value to be associated with a single key in a dictionary. So in the earlier example of favorite programming languages, if we were to store each person's response in a list, people could choose more than one favorite language. So when we loop through the dictionary, the value associated with each person would be a list of languages rather than a single language. So for the programming languages dictionary, in this time we use list to store the value for the languages each person like. For example, field, there are 2 programming languages, and Jan also 2 programming languages, but for Scala only 1 programming language. Next, we can write a for loop for name language in favorite languages item. The item method will get a key value pairs. So key is the name, language is the value of this person. Then we can print name, the titles forms, favorite languages are. Next, inside the for loop, we'll write another for loop. Because this is a list, so we can write a for loop for language in languages. So languages is a list here. Key value pairs, the value for this key, for example, is a list. Next, we can write a for loop for the value for each item in this list, then print out each language. We create favorite languages dictionary with value as list. Then for each people, we will print out his favorite languages. So this is the result. Jan's favorite languages are Python, Ruby. Scala's favorite languages are C, so on. And the last case is dictionary in a dictionary. So you can nest a dictionary inside another dictionary, but your code can get very complicated quickly when you do this. For example, if you have several users for a website, each with a unique username, you can use the usernames as the keys in a dictionary. You can then store information about each user by using a dictionary as the value associated with their username. So in the following listing, we store 3 pieces of information about each user: their first name, last name, and the location. We will access this information by looping through the usernames and the dictionary of information associated with each username. We create a dictionary. So inside of this dictionary, for the key Einstein is a person, then we store another dictionary as the value of Einstein, this key. And for Mercury, we store another dictionary as the value of this person. Next, inside, and for each dictionary of the value, there's a 3 information for the first name, last name, and the location for this person. Next, we can write a for loop. For loop, first use the items method for the users. User is a dictionary, main dictionary. Then items will get the list of username and the user info pair. Then print a message. Then we create variable called full name is user info. User info is a dictionary. User info's first name plus username info's last name concatenated with a space. Then location is user info's location's value. Next, we can print message with full name and location, title form. So create a dictionary with 2 scientists as the key and dictionary including first name, last name, and location as this person's value. Next, run a for loop which extracts the information of the key is the username and the user info is the dictionary from user's items method. Then print out information of username, then create a full name with the concatenation of the user info's first name and the last name, as well as the location information, then print out. So the result is username Einstein, then full name Albert Einstein, location Princeton, and similarly for username Marie Curie. In this lecture, you will learn how to accept the user input in Python, so your program can then work with it. When your program needs a name, you will be able to prompt the user for a name. When a program needs a list of names, you will be able to prompt the user for a series of names. To do this, you will use the input function. How the input function works? The input function pauses your program and waits for the user to enter some text. Once Python receives the user's input, it will store it in a variable to make it convenient for you to work with. For example, we can use input function, and this is a prompt to the user. User will see this prompt. So tell me something and I will repeat it back to you. Then after user has input the text of something, then this will store in the message variable. Next, we can print out this message. For example, we can try this. The user will see this, tell me something, and I will repeat it back to you. I try, for example, hello everyone. Then this information has been stored in the message. Next, we can print out this message. Hello everyone. So the input function takes one argument, the prompt or instructions that we want to display to the user so they know what to do. In this example, when Python runs the first line, the user sees the prompt, tell me something, and I will repeat it back to you. The program waits while the user enters their response and continues after the user presses enter. And the response is stored in the variable message. Then print message displays the input back to the user. And when you run input in Spider, sometimes comes with internal problem with this function. One way to solve this problem is to upgrade the Spider to version 5.3.0 using command and Anaconda prompt. So you can start Anaconda prompt in Windows Start menu, activate your environment. You have create an environment called NumPython, for example. Then you activate this NumPython environment, use conda activate NumPython. Then you can install Spider with the version 5.3.0 using this command pip install spider equals 0 double equal. After it is successfully finished, then check if the version of Spider is 5.3.0. You can use conda list Spider will show this information. Then you start Spider from Windows. You start menu Anaconda. So writing clear prompts. Each time you use the input information, you should include a clear, easy-to-follow prompt that tells the user exactly what kind of information you are looking for. Any statement that tells the user where to end should work. For example, add a space at the end of your prompt after the colon in the preceding example to separate the prompt from the user's response and to make it clear to your user where to end their text. So for example, you can set the prompt to input as please enter your name, here with a space. Try. And build a multi-line string for the prompt. Sometimes you will want to write a prompt that's longer than one line. For example, you can store your prompt in a variable and pass that variable to the input function. This allows you to build your prompt over several lines, then write a clean input statement. For example, we can store prompt first with this message. If you tell us who you are, we can personalize the messages you see. Then we can use plus equal to add a new line with another information to this prompt variable. So next we can use input function and passing this prompt. So user will see if you tell us what you are, what's your first name, 2 lines information prompt. So we create prompt this line first. Then we add another line to this block. Then we use input and with this block to the user. The user will see two lines for the block. Try the name, Wilson. Then next we can print out this name. Hello Wilson. Using int to accept a numerical input. So when you use the input function and the user inputs a number, Python interprets it as a string. If all you want to do is print the input, this works well. But if you try to use input as a number, you have to use the int function, which tells Python to treat the input as a numerical value. The int function converts a string representation of a number to a numerical representation as shown here. So user will see this prompt, how old are you? So if, for example, if he inputs 21, then the age will store this 21, but this value is a string. So next, you can use int function to change this string value to a numerical variable. Then we can use some numerical comparison. For example, if his age is older than 18. We tried how old are you in inches. $25, for example. Then we store this height variable and change to int form. Use int function. So now height can be used to do some numerical comparison. For example, if height is larger than 36, print this message. If not, then print else message. So you will be able to write when you are a little older. Yeah, this is the code what we have used. The modulo operate. A useful tool for working with numerical information is the modulo operate, which divides one number by another number and then returns the remainder. So we use the percent symbol for the modulo operation. For example, 4 modulo 3 will get 1, and 5 modulo 3 will get a 2 here. Get 2 here. The following program will tell the input value is even or odd using modulo operation. So user will input something according to this prompt, enter number, and I will tell you if it's even or odd. Then use int function to change this number as a numerical variable. Then we can use an if statement test to test if the number is modulo 2 will be 0. If modulo 2 0, then this number is an even number. Will print is even information. If not, then this number is odd number. So first we'll accept a user input. For example, input 19. Then use int function to set number as numerical value. Then we can run this if-else statement. So the number 19 is odd. The for loop takes a collection of items and executes a block of code once for each item in the collection. In contrast, the while loop runs as long as or while a certain condition is true. You can use a while loop to count up through a series of numbers. For example, the following while loop counts from 1 to 5. We set current number to the first initially. Then we do a while loop. Check if current number less than or equal to 5, then print this current number. Then inside this while loop, we also increase this current number with 1. Then it will go back, check again if this condition still true. So and so on until run the current number if not less than or equal to 5, then the while loop stops. So in the first line, we start counting from 1 by setting the value of current number to 1, and the while loop is then set to keep running as long as the value of current number is less than or equal to 5. The code inside the loop brings the value of current number and then adds 1 to that value with current number equals 1. And this operator is shorthand for current number equals current number plus 1. For Python repeats the loop as long as the condition current number less than equal to 5 is true. We show current number equals 1 assigned with 1 first. So while loop, while this condition is true, will print out this number and then increase this number with 1. So this 5 number is being printed out. So letting the user choose when to quit. So in the following program, we define a while loop. We then define a quit value and then keep the program running as long as the user has not entered the quit value. So prompt, we create prompt value message, the 2-line, tell me something and I will repeat it back to you. And enter quit to end the program. So we start with an empty string called message. Then our message is not quit, is not equal to quit. If this is true, then we will let user to input some message with this prompt. Next, then print message. So this while loop will run until user input quit. So if user do not input quit, this while loop will always run forever to end to print the message you have input. But if you input quit, then while loop will stop immediately. So we create this prompt variable, then create empty message, then run this while loop and let the user to input this message and print out this message. Try hello. So print out hello has been printed out. Okay. Everyone print out. So now we input a quit. So quit print out and while loop stopped. This program works well, except that it prints the word quit as if it were an actual message. So actually quit is not the message you wanted to be printed out. The simple if test fixes this. This is same 2-line prompt and same for start with an empty message. Then inside the while loop, we can get the input from the user. Then we will test if this message not equal to quit, then we can print this message. So if this message is quit, we will not print out this message. So we can try this. This is the same as before. Then the while loop has been changed with adding an if statement. If the message is not quit, then we print out this message. Then hello. Then hello is printed out. Everyone printed out. But we input a quit, the message not printed out, and while loop also stopped. using a flag. So in the previous example, we had the program perform certain tasks while a given condition was true. But what about more complicated programs in which many different events could cause the program to stop running? So if many possible events might occur to stop the program, trying to test all these conditions in one while statement becomes complicated and difficult. So for a program that should run only as long as many conditions are true, you can define one variable that determines whether or not the entire program is active. This variable, called a flag, acts as a signal to the program. So we can write our program so they run while the flag is set to true, and stop running while any of several events sets the value of the flag to false. So let's add a flag to the previous program. This flag, which we will call active, so you can call it anything, will monitor whether or not the program should continue running. So we set create to their message, prompt message. Then we create a variable called active is true. Next, we will run a while loop. Start with while active. So while active means if the active's value is true, then while active will be true. If the active's value is not true, so while active will not be true. So the while loop starts with while active. So the message, user will input a message. So if the message equals quit, then we'll set active to false. If the message is not quit, then we will print this message, then run while loop again. Until user input quit, we will set active to false, then while loop will stop. We create this prompt message, then set a flag variable active to true first. Then run a while loop. While active, then user can input a message and Python will check if the message is quit. If quit, then while loop stopped, and active, because active set to false, then the loop will stop. If it is not quit, then we'll print out this message and back to the while loop check again. So we run. Hello, everyone, then quit is stopped, while loop stopped. Using break to exit a loop. To exit a while loop immediately without running any remaining code in the loop. So regardless of the results of any conditional test, you can use the break statement. The break statement directs the flow of your program. You can use it to control which lines of code are executed and which aren't. So the program only executes code that you want it to when you want it to. For example, consider a program that asks the user about places they have visited. So we can stop the while loop in this program by calling break as soon as the user enters the quit value. So this is 2 lines message. Prompt the user to tell a city they have visited and can enter quit if they are finished. So a while loop with while true start. So while true is always true if nothing else happened. So while true is always true. Then prompt the user to input a city. So next is if test. If the city is quit, then break. Then while loop stopped. If the city is not quit, then a message I'd love to go to this city are printed out. The loop that starts with while true will run forever unless it reaches a break statement. You can use the break statement in any of Python's loop. For example, you could use break to quit a for loop also. That's working through a list or a dictionary. So we'll show this code. First, create this prompt message variable. Then we will run this while loop. So user will see this prompt, enter city, print New York. Then the message "I'd love to go to New York" printed out. Next, I will input London. Then I'd love to go to London. Then here now I have input quit. So the while loop stopped. And you can also use continue in a loop. So rather than breaking out of a loop entirely without executing the rest of its code, you can use a continue statement to return to the beginning of the loop based on the result of our conditional tests. So for example, consider a loop that counts from 1 to 10 but prints only the odd numbers in that range. So we create the first value of current number is 0. Then we run a while loop for the test if current number is less than 10. So at the beginning it is true because 0 less than 10. So run the while loop inside the loop. First we add 1 to this number. Then we if test if this number modulo 2 equals 0, which means it is an even number, then it will continue. So continue will go back to the while loop and without running the rest of code in the while loop, but not stop this while loop. Just skip the rest of the code and back to the while loop. So if it is an even number, we do nothing, just back to the while loop. But if it is not even number, it's an odd number, then we print this number and back to the while loop also. So first we set the current number to 0 because it's less than 10. Python enters the while loop. So once inside the loop, we increment the count by 1. So current number is 1. And the if statement then checks the modulo of current number and 2. If the modulo is 0, which means current number is divided by 2, the continue statement tells Python to ignore the rest of the loop and return to the beginning. So if the current number is not divisible by 2, the rest of the loop is executed and Python prints the current number and back to the while loop again. So we will show current number is 0. Then a while loop will print out only odd number. So only odd number 1, 3, 5, 7, 9 are printed out, and the even number not printed out, and the code using continue. So you will not stop the while loop, just skip the rest of the code in this run. To keep a track of many users and pieces of information, we will need to use lists and dictionaries with our while loops. A for loop is effective for looping through a list, but you shouldn't modify a list inside a for loop because Python will have trouble keeping track of the items in the list. To modify a list as you work through it, use a while loop. Using while loops with lists and dictionaries allows you to collect, store, and organize lots of inputs to examine and report on later. So we can move items from one list to another. So consider a list of newly registered but unverified users of our website. After we verify these users, how can we move them to a separate list of confirmed users? One way would be to use a while loop to pull users from the list of unconfirmed users as we verify them, and then add them to a separate list of confirmed users. So this is a list of unconfirmed users. Then we create an empty list called confirmed users. The next use a while loop. So while loop, the purpose of this while loop is to move each unconfirmed users to verify and then to confirm the users list. So while unconfirmed users means if unconfirmed users list is not empty, there are users in this list, then we will run the while loop. So we use a pop function to take one the last one of this list, last item of this list out, then store in a current user. Then we print a verifying message. Then in confirmed users list, we append this current user. So this process will run until there are no items left in unconfirmed users. Then next, we can write a for loop to print out each confirmed users from this confirmed users list. We set a unconfirmed users list first. Then create confirmed user list with empty. So run a while loop to move every unconfirmed user out, verifying them and put in confirmed users list. So verifying user, each being done. Then we print following users have been confirmed. Then for loop for the confirmed users list, each item will be printed out. And you can remove all instances of specific values from a list. The remove function will remove the instance that appeared only once in the list. But what if you want to remove all instances of a value from a list? Say you have a list of pets with the value cat repeated several times. To remove all instances of that value, you can run a while loop until cat is no longer in the list. So this is a list with pets. The cat occurs 3 times here. Then we can write a while loop. So while cat in pets, then we will remove cat. So while cat in cat means while cat exists in this list, it still have cats list exists in this list, then we'll remove this cat. So until there are no cat in these pets, then the while loop will be finished. So we create these pet lists and print cat, cat, cat. Then a while loop will remove each one cat in the list, and we print pets again. There are no cats now in the list. So filling a dictionary with user input. So you can prompt for as much input as you need in each pass through a while loop. So let's make a pooling program in which each pass through the loop prompts for the participant's name and the response. We can store the data we gather in a dictionary. So first we create an empty dictionary, then set a pooling active flag to true. So while pooling active, then user will see prompt what is your name. Then the response is input and user input name to name variable. Similarly, user will input the mountains information for the response variable. Then int for the dictionary, this dictionary created here, we add key value pairs for name, the person, and its response, the value of this mountain. Then repeat is another input for user to enter. The prompt is would you like to let another person respond? So if the user does not enter no, then process will be continue and the user can do back to the while loop, and the user can input again the name and the information for the response with mountains, then add another key value pairs in dictionary. So this process will until user enter no in the repeat input. If the user enter repeat input with no, then pooling active flag will be false. So back to the while loop, pooling active will not be successful, then the while loop is stopped. So next, then we can print out information from this dictionary with function items and get name response pairs, each name response pairs, and print it out in this message. So we set this empty dictionary first, then while loop. In the while loop, user will enter name and response of the mountain, and while loop will set key value pairs in this dictionary. Then user will see another prompt. Would you like to let another person respond? If the user does not enter no or enter yes or other input, then the while loop will continue on, and user then enter another name and mountain, and so on until user has entered no here. Then the key pooling active flag will be false. Then the while loop will be stopped. So we run this process. Okay, we have to define pooling active first. Then what's your name? Wilson. Himalaya is mountain. Would you like to let another person respond? Yes. What's your name? Shirley. What mountain would you like to climb someday? Kilimanjaro. Would you like to let another person to respond? This time enter no. So the while loop stopped. Then we print out the results. Pulling results, and for name items, a for loop to get out all the key value pairs in this dictionary, and print out all information. Wilson would like to climb Himalaya, and Shirley would like to climb Kilimanjaro. In this lecture, you will learn to write functions, which are named blocks of code that are designed to do one specific job. So when you want to perform a particular task that you have defined in a function, you call the name of the function responsible for it. If you need to perform that task multiple times throughout your program, you don't need to type all the code for the same task again and again. You just call a function dedicated to handling that task, and the call tells Python to run the code inside the function. So we define a simple function. Here's a simple function named greet user that prints a greet message. So we use diff greet user. Then this is the description of this function. Use triple quotes. Then inside the function, print a message hello. Then we can call this function just write greet user. The keyword diff to inform Python that you are defining a function. Then next name of the function is greet user. Then parentheses are empty here means no more information needed to run this function. And a comment called a docstring enclosed in triple quotes, which describes what the function does. The docstrings are enclosed in triple quotes. Greet users call the function. So we define a function called greet user, and inside the function print hello message. Then we call this function just print greet user and parentheses. The function greet user can not only tell the user hello, but also greet them by name. So for the function to do this, you enter username in the parentheses of the function's definition at the diff greet user. So by adding username here, you allow the function to accept any value of username you specify. So if we want to print message with different username, so we can put a parameter here in the definition of function in the parentheses. So inside the function, print message will take this information of username and print a message. So when we call this function, we have to add a name, for example, Jesse here. So the variable username in the definition of greet user is an example of a parameter, a piece of information the function needs to do its job. And the value Jesse in greet user Jesse is an example of an argument. An argument is a piece of information that is passed from a function call to a function. So when we call a function, we place the value we want the function to work with in parentheses. In this case, the argument Jesse was passed to the function greetUser, and the value was stored in a parameter username. Note that people sometimes speak of arguments and parameters interchangeably. So we create again this function greetUser with the username as a parameter. Then we can print out a message using this username. The function defined. Then we call this function and adding a Jesse here in the parentheses. So the message "Hello Jesse" is printed out. Because a function definition can have multiple parameters, a function call may need multiple arguments. You can pass arguments to your functions in a number of ways. You can use positional arguments, which need to be in the same order the parameters were written, keyword arguments, where each argument consists of a variable name and a value, and the lists and dictionaries of values. So, positional arguments. When you call a function, Python must match each argument in the function call with a parameter in the function definition. The simplest way to do this is based on the order of the arguments provided. So values matched up this way are called positional arguments. To see how this works, consider a function that displays information about pets. The function tells us what kind of animal each pet is and the pet's name. We define a function called describePet with two parameters needed to run this function. First is animal type, second is pet name. Then in the function definition, we print a new line, then a message "I have this type, animal's type." Then print another line, this animal type's name is this pet name's title form. So when you call this function, you have to write describePet, then the type first, then name second. Or you can run again, call the dog is the type, then Willie is the name. So we define this function first. Then we call this function. Then I have a hamster. My hamster's name is Harry. We call again with this information input. I have a dog. My dog's name is Willie. So order matters in positional arguments. You can get unexpected results if you mix up the order of the arguments your function call when using positional arguments. So for example, if you call this function but write this order, Harry hamster, so this will print the message "not you want." And a keyword arguments. A keyword argument is a name-value pair that you pass to a function. You directly associate the name and the value within the argument. So when you pass argument to the function, there is no confusion. Keyword arguments free you from having to worry about correctly ordering your arguments in function call. So let's rewrite the pets examples using keyword arguments to call describePets. So we can also call this function. Then in the parentheses we write key value. So you can write any order if you input the key value pairs. And we can also call a pet name, right first, Harry, and animal type second. it's correct. So the order of keyword arguments doesn't matter because we explicitly tell Python which parameter each argument should be matched with. So we call using keyword arguments. So I have a hamster, my hamster's name is Harry. Then call again with this keyword order. So I have a hamster, my hamster's name is Harry. The return result is the same. And default values. So when writing a function, you can define a default value for each parameter. If an argument for a parameter is provided in a function call, Python uses the argument value. If not, it uses the parameter's default value. For example, if you notice that most of the calls to describe a pet are being used to describe dogs, so you can set the default value of animal type to dog. Now anyone calling describe pet for a dog can omit that information. We can define this function with pet name, but animal type we set a default value as dog. So when you print, when you call this function, if it is a dog, you can just input the name of this pet. You need not input a dog, but the function definition with the default value have to be put after the argument parameter without default name, without default value. So dog, because the default value for animal type is dog, so we have to put this parameter in the end in the function definition. So when we call this function, we can also write pet name Willie. So in both calling without animal type in the input, so the function will assume that animal type is dog. So we create this function with the default value with dog for the animal type. Then call this. So I have a dog, my dog's name is Willie. So this information is for name. And I call again. I have a dog, my dog's name is Willie. To get the same result. Notice that the order of the parameters in the function definition had to be changed because the default value makes it unnecessary to specify a type of animal as an argument. So the only argument left in the function call is the pet's name. So Python still interprets this as a positional argument. So if the function is called with just a pet's name, that argument will match up with the first parameter listed in the function's definition. So this is the reason the first parameter needs to be pet name. And the simplest way to use this function now is to provide just a dog's name in the function call. And to describe an animal other than dog, you could use a function call like this. So if we describe a pet, but the pet is not a dog, so we have to input pet name is Harry and animal type is hamster. Because the position arguments, keyword arguments, and default values call can be used together, often you will have several equivalent ways to call a function. For example, we will have a dog, the name is Willie, so we can describe a pet, Willie, which we have seen, and describe a pet name is Willie, these two we have learned. And if a hamster name is Harry, we can write Harry here, hamster second, because this is in the definition is the second place for the type, but with a default value because the hamster is not dog, so we have to input hamster here. But you can also write pet name is Harry, animal type is hamster. This is very clear. And because we use keyword and value type, so we can also write animal type first, hamster, then pet name Harry second. No problem. This it works correctly. So we will try this equivalent course. So these two we have run. I have a dog, my name is Willie. Then if I have a hamster named Harry, can run this first. Then can run this calling. We get the same result. My hamster's name is Harry. And this one also correct. My hamster's name is Harry. Return values. A function doesn't always have to display its output directly. Instead, it can process some data and then return a value or set of values. The value the function returns is called a return value. The return statement takes a value from inside the function and sends it back to the line that called the function. So returning a simple value. Let's look at a function that takes a first and a last name and returns a neatly formatted full name. So this is a function definition. Get formatted names with two parameters, first name and the last name. Then inside the function, a full name variable is created with a concatenation of first name, space, and the last name. Then a return statement return full name's title form. So when we call this function get formatted name with input information for first name and the last name, then the return value of this full name's title form will be saved back to musician. Then next we can print this musician. We create this function and call this function and store return value full name to musician. And we print out this musician, Jimi Hendrix, exactly same as what we have inputted. So making an argument optional. Sometimes it makes sense to make an argument optional so that people using the function can choose to provide extra information only if they want to. You can use default values to make an argument optional. For example, say we want to expand get formatted name to handle middle names as well. The first attempt to include middle names might look like this. So we need middle name in this function. So normally people may write like this: first name, middle name, last name in as the parameters. Then inside the function definition, a full name is concatenated from first name, space, middle name, space, and last name. Then return this full name's title form. When people call this function, just write get formatted name with first, middle name, and last name. So we try this function definition and call this function with first name, middle name, and the last name. Is a positional argument, passing position argument. So then after calling this function, the musician will get the value of this returned value full name. Then we print this musician. So first name John Hooker Lee printed out. This function works when given a first, middle, and a last name. The function takes in all three parts of a name and then builds a string out of them. But middle names aren't always needed, and this function as written would not work if you try to call it with only a first name and a last name. So this function does not work when people have not middle name. to input. So a better solution would be to make middle name optional. So we can give the middle name argument an empty default value and ignore the argument unless the user provides a value. So this is a better solution for definition of this function. So inside the parenthesis position, we write first name, last name, then middle name and last with a default value of empty string. Then inside the function, we use if-else test. So if middle name means if the middle name is not empty, which means if user inputs some middle name, then the full name is the concatenation of these three names together. Else means if user did not input the middle name, so full name is only first name concatenated with the last name. Then in the end, function will return full name, the title form. So when we call this function, no matter whether the people has middle name or not middle name, this function works. So in this case, we call this function with only first name and last name. Then in this case, we can call function with first name, last name, and middle name. Just note middle name have to be put in the last place, because in the definition, first name, last name is a middle name. We create this function first with middle name as default, has a default empty string. Then we call this function with only first name and last name. Then we print so only first name, last name. And we call this function with first, last, and middle name input. Then print this musician. Now three name, first name, middle name, and last name. A function can return any kind of value you need it to, including more complicated data structures like lists and dictionaries. For example, the following function takes in parts of a name and returns a dictionary representing a person. We define a function called buildPerson. And information in parameters are first name, last name. So the person is a dictionary created in the function. And for this dictionary, there are two key value pairs. First is the first value is the first name from the parsing of this first name, and key last, the value is last name passed from these positions parameter. So then function return person, this dictionary, when you call this function. So next we call this function buildPerson, then with information for first name, last name passing. We create this function with a return a dictionary of a person. Then we call this function and with passing first name and the last name, and stored back to the musician. So the musician is a dictionary because this function returns a dictionary. So we print out this musician is a dictionary with first two key value pairs. Key first value is Jimmy, last is key, the value is Hendrix. And you can easily extend this function to accept optional values like a middle name, an age, an occupation, or any other information you want to store about a person. For example, the following change allows you to store a person's age as well. So we define a function called buildPerson, but this time we add another parameter called age with default value is empty string in addition to first name and the last name. So inside the function, we create a dictionary called person with two key value pairs, first and last first. Then we run a if test if age. So if age means if user inputs age when calling this function, then we create another key value pair for this person's dictionary. Then key is age and the value is the age user input. Then in the end we return this person dictionary. So when you call this function, you input Jamie, Henrik's first name, last name, then you add a key value pair like age equals 27. Then the musician will be a dictionary include information with a key value pair for first name, last name, and age. We define this function with age as a default empty string value in addition to first name and last name, and return this person if age is input with a value, then the person has key value pair for age also. And we call this function, and the return person's dictionary will be stored in the musician with input Jamie, Hendrix, and age 27. Then we print out this musician. So now musician is a dictionary with three key value pairs: first name, last name, and age. Using a function with a while loop, you can use functions with all the Python structures you have learned about so far. For example, let's use the getFormatTheName function with a while loop to greet users more formally. It is the first attempt at greeting people using their first and last names. So you can define a function with two parameters, first name, last name. Then inside the function, create variable called full name with the concatenation of first name, space, and last name. Then return these full names title form. Then we write a while loop. So while true, it will be always true if nothing happens. So in the while loop, print message for the user to input a name, and if user input a Q, then it will be quit. Then the while loop will stop. Then next, create two variable called fName, get the information of the first name, the lName get information of last name user input. Then format the name, calling this getFormatTheName function, and store the return value of full name to format the name. Then print message including this formatted name. In the previous example, we use a simple version of getFormatTheName that doesn't involve middle name. And the while loop asks the user to enter their name, and we prompt for their first and last name separately. But there is one problem with this while loop. We haven't defined a quit condition, and the while loop will be run infinitely. We want the user to be able to quit as easily as possible, so each prompt should offer a way to quit. The break statement offers a straightforward way to exit the loop at either prompt. In the following example, we add a message that informs the user how to quit, and then we break out of the loop if the user enters the quit value at either prompt. So the program will continue greeting people until someone enters Q for either name. So we change the while loop here. After user see the input for the first name, after user input, there will be a if conditional test. So if user inputs Q for the first name, then it will be break. Then the while loop will stop. Now if the next for L last name input from the user also will be a if test. If this time user input Q, then also will be break. we try to use this, create this function first, then we run a while loop which include q if user input. So first name Wilson, last name Shirley, then hello Wilson Shirley, then first name James, last name Wilson, then print it out. Then we input q and the while loop stopped. Passing a list to a function. You will often find it useful to pass a list to a function, whether it is a list of names, numbers, or more complex objects, such as dictionaries. When you pass a list to a function, the function gets direct access to the contents of the list. Say we have a list of users and want to print a greeting to each. The following example sends a list of names to a function called greetUsers, which greets each person in the list individually. So we define a function called greetUser with parameter called names, and the names is a list. So inside the function, there's a for loop for name in names. So get each element of this names list, then set it to variable name. Next, we create a message with the concatenation of hello and the names title for, then print this message. So when we call this function, we create a user names with 3 names in this list, then call this function greetUsers with passing this user names list. We define this function first, then create a list called usernames, and call this function with passing this list. Then greeting message for each person in the list has been printed out. Hello Hannah, hello Chai, hello Margot. Modifying a list in a function. When you pass a list to a function, the function can modify the list. So any changes made to the list inside the function's body are permanent. Consider a company that creates 3D printed models of designs that the users submit. So designs that need to be printed are stored in a list, and after being printed, they are moved to a separate list. The following code does this without using function. So if we do not use a function, we will use the following codes. So we create a list called unprinted designs with 3 elements, then create a completed models with empty list first. Then we write a while loop. So while unprinted designs, if there's any element left in unprinted designs, then we pop out this element, the last element in this list, then set to current design. Then we print a message, so printing model, printing this current design now. Then we append this current design to this completed models list we created here. So when the while loop runs until unprinted design is empty, because we pop it out empty. So then the while loop are finished and all items have been moved from the unprinted design to the completed models. So next we can print out this information for each completed model in the completed models list. So we create these 2 lists, then use a while loop to move all items from unprinted design to completed models. So printing models, each element has been printed. Then we print a message following have been completed, then a for loop in this completed models list, print each model. Each model has been completed. So we can recognize this code by writing two functions, each of which does one specific job. The first function will handle printing the designs, and the second will summarize the prints that have been made. So we define the function print models with two parameters, a list of designs that need to be printed and a list of completed models. So given these two lists, the function simulates printing each design by printing the list of unprinted designs and filling up the list of completed models. Then define a function called showCompleted with one parameter, the list of completed models. So given this list, showCompleted function will display the name of each model that was printed. So this is the code. So we first define a function called printModels. So there are two parameters, unprinted designs and completed models. Both are lists. So then inside the function is a while loop, very similar to the while loop we see in the previous pages. Then the current design is the pop value from the unprinted designs if unprinted design is not empty. Then we print a message, we print this current design now. Then we append this current design to the completed models list. The next, another function called showCompleted with one list as parameter, completed models. So we print a message, then for completed models, each completed model in completed models list will print this model. So we call this function, we first define two lists. One is unprinted designs with 3 elements. One is completed models with empty value, initial empty value. Then we call printModels function with unprinted design and completed models as input to the parameter. Then we call showCompleted with completed models as input. So we run first define these two functions called printModels and showCompleted. Then we define two lists. One is unprinted design and one is complete design with empty lists. Then we first call printModels with input as unprinted design and completed models as parameter input. So 3 models has been printed. Then we show the printed models. So the completed models now has 3 elements, and if we run show the unprinted design again, it is empty now. So which means for the calling this function, printModel calling this line, we input two lists, and both have been changed. So for the unprinted designs, it's empty now, and for the completed models, it's now full of 3 completed models. So passing lists to the function will be changed. And preventing a function from modifying a list. So sometimes you want to prevent a function from modifying a list. For example, say that you start with a list of unprinted design and write. In this case, you can address this issue by passing the function a copy of the list, not the original. So any changes the function makes to the list will affect only the copy, leaving the original list intact. So you can send a copy of a list to a function like this. So if we call this function again, we can use the bracket colon. This is a copy of this list. So this list will not be changed after running the function. The slash notation makes a copy of the list to send to the function. If we did not want to empty the list of unprinted designs in previous example, we could call print models like this. So print model unprinted design with a colon. So this list will not be empty after we have called model. We try this. So these two lines are the same as before. We create two lists. One is unprinted design and one is empty design, empty for the complete models at first. Then we call this function called print model with unprinted designs, but we use a colon here. So unprinted designs, this list, original list will not be affected. But completed models, this list will be affected, will be filled with each element from unprinted designs. So we call, then we call again for show completed models. So the complete models has 3 elements now, and we run unprinted design still has 3 elements. Passing an arbitrary number of arguments to function. Sometimes you won't know ahead of time how many arguments a function needs to accept. Fortunately, Python allows a function to collect an arbitrary number of arguments from the calling statement. For example, consider a function that builds a pizza. It needs to accept a number of toppings, but you can't know ahead of time how many toppings a person will want. The function in the following example has one parameter, asterisk toppings, but this parameter collects as many arguments as the calling line provides. So we define a function called makePizza with the parameter asterisk toppings. Then we print these toppings. And when we call this function makePizza, we can input one argument pepperoni, or we can input with 3 or many more arguments when we calling this function. So the asterisk in the parameter name toppings tells Python to make an empty tuple called toppings and pack whatever values it receives into this tuple. So in these two cases, pepperoni or mushrooms, green peppers, extra cheese will be stored in these star toppings, and this asterisk toppings will be a tuple, will be used in the function. We make function called makePizza with asterisk toppings as the parameter. Then we call this function, this time with only one item, pepperoni, as the argument for this parameter. Then to in output, print this one with tuple with only one element. Then this time call this function, but with 3 toppings as arguments input. Then Python will print out a tuple with 3 elements. Now you can replace the print statement with a loop that runs through the list of toppings and describes the pizza being ordered. We can make some change for this function. Then we can print a statement and then a loop for each topping inside this toppings list. So this tuple is also a list. Then print out each topping. We create this function again. Then we call with the same argument as before. Now the message, make a pizza with the following toppings: pepperoni. And call this function with 3 arguments passing. Then make a pizza with the following toppings with these 3 toppings. And mixing positional and arbitrary arguments. If you want a function to accept several different kinds of arguments, the parameter that accepts an arbitrary number of arguments must be placed last in the function definition. Python matches positional and keyword arguments first and then collects any remaining arguments in the final parameter. So for example, if the function needs to take in a size for the pizza, such parameter must come before the parameter asterisk toppings. So in the function definition, Python stores the first value it receives in the parameter size. All other values that come after are stored in the tuple toppings. So the function calls include an argument for the size first, and followed by as many toppings as needed. So we make modification for this function definition. Then this time there are 2 parameters. The first is the size for the pizza. The next is an arbitrary number of arguments will be stored in this toppings tuple because there are asterisk here. Then inside the function we print a message using the string value of this size. Then in a for loop, same as before, we print out this topping. So when we call this function, the same form for the calling as before, but this time we add size first. Have to add size first because size is stay the first position in the parameter in the function's definition. So size first, then next either is 1 items or 3 items will be stored as this toppings tuple. So we make a new function with size and this toppings tuple as parameter. Then we call this function again with the size first, then pepperoni second. Then a message, we make a 16-inch pizza with the following toppings: pepperoni. We call again this function with size 12 first, then 3 items second. Then we make a 12-inch pizza with the following toppings: mushroom, green peppers, extra cheese. And using arbitrary keyword arguments. Sometimes you will want to accept an arbitrary number of arguments, but you want to know ahead of time what kind of information will be passed to the function. In this case, you can write functions that accept as many key value pairs as the calling statement provides. One example involves building user profiles. You know you will get information about a user, but you're not sure what kind of information you will receive. The function build profile in the following example always takes in a first and a last name, but it accepts an arbitrary number of keyword arguments as well. So in this function's definition, this function called build profile, we have two parameters called first and last. This is like a normal parameter. Then is a double asterisk user info. So this will be stored as a dictionary in the function's definition. So in the function, we define an empty dictionary first. Then we'll create the keys of this dictionary, and with the value coming from the passing of this parameter, same as for the last name. Then next we write a for loop for this dictionary's items methods will get a key value pair. That for each key value pair in these dictionaries items, then we will create new key and value pairs and use this information from this user's info. So this user's info is a tuple or is a dictionary. When we call this function, and the extra information after first and the last, these two values will be stored in this dictionary. So this for loop will use this dictionary and put these key value pairs in dictionary profile. Then in the end, function returns this profile, the dictionary, which include all the key value pairs from last name, first name, last name, and user infos. So when we call this function, we will add first, last name's value first. Then we will add several key value pairs as we want. So we create this function with first, last, then a dictionary as parameter. We call this function with Albert Einstein as first and last name, then location as Princeton, field is physics as two extra key value pairs. Then we print this user file. So the print result will be a dictionary with 4 key value pairs. So first name Albert, last name Einstein, a location Princeton, and a field physics. Once you have created a function or a dozen functions, you can go a step further by storing your functions in a separate file called a module, saved into same directory as your current source file, and then importing that module into your main program. An import statement tells Python to make the code in your module available in the currently running program file. So storing your functions in a separate file allows you to hide the details of your program's code and focus on its higher level logic. It also allows you to reuse functions in many different programs. So when you store your functions in separate files, you can share those files with other programs without having to share your entire program. There are several ways to import a module. So importing an entire module. To start importing functions, we first need to create a module. A module is a file ending in .py that contains the code you want to import into your program. So let's make a module file called pizza.py that contains the function make pizza. So this function is written in the file pizza.py in the working directory. So this function is same as the function we made in the previous lectures, with size and these tuple toppings as input parameter. Then print a message with the size of this pizza and print out each topping. So this file called pizza.py is a module file stored in the working directory, and their own function in this file called make pizza. Then first we set the working directory. Then we can import the module pizza. We just create it and then make 2 calls to make pizza using the for. So we can first import this module called import pizza. Pizza is a file. pizza.py, but we have need not add extension here, just import pizza. Then we can call this function makePizza using pizza.makePizza. Then is the argument for the input. Similarly, we can use pizza.makePizza and input with size, then more than one toppings for the pizza. So when Python reads this file, the line import pizza tells Python to open the file pizza.py and copy all the functions from it into this program. To call a function from an imported module, enter the name of the module you imported, pizza, followed by the name of the function makePizza, and separated by a dot. This code produces the same output as in the previous lecture, that without storing function into a module. So we import pizza first. Then we can use makePizza.pizza with argument parsing. So output making a 16-inch pizza with the following toppings: pepperoni. Similarly, we can call this pizza with 3 toppings and 1 size. So that's correct. And you can also import specific functions from this import module file. You can also import a specific function from a module. Here is the general syntax for this approach. You can also write like from module name, import this function name. So you can import as many functions as you want from a module by separating each function's name with a comma. So if the module file contains more than one function and you want to import these functions, you can write from module name, this file, import the function, first function, second function, third function, and so on. So the makePizza example would look like this if we want to import just the function we are going to use. So we can write from pizza import makePizza. Then when we call this function, we just use makePizza with the argument makePizza with this argument. So with this syntax, we don't need to use the dot notation when you call a function, because we have explicitly imported the function makePizza in the import statement. So we can call it by name when we use the function. So this time we just import this makePizza function from this file. Then we can call this function, just use makePizza. Call this function with 3 toppings. And using s to give a function an alias. So if the name of a function you are importing might conflict with an existing name in your program, or if the function name is long, you can use a short unique alias, an alternate name similar to a nickname for the function. You will give the function this special nickname when you import the function. The general syntax for providing an alias is like, so from module name, import function name is an alias. So here we give the function makePizza an alias mp. So by importing makePizza as mp, so the s keyword renames a function using the alias you provide. So you can write from pizza import makePizza as mp. Then we can call this function using mp now with the parameter parsing. mp now with the parameter parsing. We can from pizza import makePizza as mp. Then we can use mp16 pepperoni to call this function. You can make a call with mp12 mushroom, green peppers, extra cheese. So the output of this calling is the same. We use as to give a module an alias. You can also provide an alias for a module name. The general syntax for this approach is import module name as an alias. So giving a module a short alias, like p for pizza, allows you to call the module's functions more quickly. So calling p.makePizza is more concise than calling pizza.makePizza. So we can import pizza as p. So we can call module with p.makePizza. p.makePizza. So we can import module as p. Then call module with p.makePizza 16 pepperoni. P.makePizza 12 and with 3 topping. So the result is the same in the printing. And you can also import all functions in a module. You can tell Python to import every function in a module by using the asterisk operator. So we can write from pizza import this asterisk, means all the function. Next, we can also use make pizza with the parsing. The asterisk in the import statement tells Python to copy every function from the module pizza into this program file. Because every function is imported, you can call each function by name without using the dot notation. However, it's best not to use this approach when you are working with large modules that you didn't write. If the module has a function name that matches an existing name in your project, you can get some unexpected results. Python may see several functions or variables with the same name, and instead of importing all the functions separately, it will overwrite the functions. So this is not a good approach. We write here just to let you know if in the later time you may see such approaches in other people's code. So we can try this, make from pizza import with the asterisk. Then we can call this function with just to make pizza. The result is the same. So the best approach is to import the function or functions you want, or import the entire module and use the dot notation. Class object-oriented programming is one of the most effective approaches to writing software. In object-oriented programming, you write classes that represent real-world things and situations, and you create objects based on these classes. When you write classes, you define the general behavior that a whole category of objects can have. And when you create individual objects from the class, each object is automatically equipped with the general behavior. You can then give each object whatever unique traits you desire. Making an object from a class is called instantiation, and you work with instances of a class. You can also specify the kind of information that can be stored in instances. So creating a dog class. So let's start by writing a simple class, dog, that represents a dog, not one dog in particular, but any dog. So they have all a name and age. We also know that most dogs sit and roll over. These two pieces of information, name and age, and those two behavior, sit and roll over, will go in our dog class because they are common to most dogs. After our class is written, we will use to make individual instances, each of which represents one specific dog. So this is a dog class. So class dog. Then this is a description of this class. Then we define df initial method. So every class has an initial method with the parameter self and a name age. Then inside this method function, then we define self.name is a name, because we need a name when we create this class for instantiation, and self-age is the age, these two information. Then we define two functions or called methods of this class. So sit, inside the sit parentheses, we pass self. So this means all the dog will have is sit method, same as roll over. Then inside of this toFunction method, then we print the name of this dog and is not sitting message. And similarly for rollover, we print this dog is rollover. So by convention, capitalize the name referred to classes in Python. The parentheses in the class definition are empty because we are creating this class from scratch. So the initial method, a function that's part of a class is a method, so everything you learned about the functions applies to methods as well. The initial method is a special method. The Python runs automatically whenever we create a new instance based on the dog class. Now, this method has 2 leading underscores and 2 trailing underscores. So there are 2 underscores here and 2 underscores. We define the initial method to have 3 parameters: self, name, and age. The self parameter is required in the method definition, and it must come first before the other parameters. And it must be included in the definition because when Python calls the initial method later to create an instance of dog, the method call will automatically pass the self argument. And every method call associated with a class automatically passes itself, which is a reference to the instance itself. It gives the individual instance access to the attributes and the methods in the class. So when we make an instance of dog, Python will call the initial method from the dog class, and we will pass dog a name and an age as arguments. The self is passed automatically, so we don't need to pass it. Whenever we want to make an instance from the dog class, we will provide the values for only the last 2 parameters, name and age. And the 2 variables defined each have the prefix self. So any variable prefixed with self is available to every method in the class. And we will be able to access these variables to any instance created from the class. So self name equals name takes the value stored in the parameter name and stores it in the variable name, which is then attached to the instance being created. The variables that are accessible through instances like this are called attributes. And the dog class has 2 other methods, defined sit and rollover, because these methods don't need additional information like a name or age. We just define them to have 1 parameter self. They all be able to sit and roll over. For now, sit and roll over don't do much. They simply print a message saying the dog is sitting or rolling over. So we create a class now. Then making an instance from class. The class dog is a set of instructions that tells Python how to make individual instances representing specific dogs. So let's make an instance representing a specific dog. So we can create a specific dog, use dog equals, then this dog is the class name, and inside parentheses is the name and age, 2 parameters needed when we define initial function in the class definition. So we tell Python to create a dog whose name is Willy and whose age is 6. When Python reads this line, it calls the initial method in dog with the arguments Willy and 6. The initial method creates an instance representing this particular dog and sets the name and age attributes with the values we provided. The instance is stored in variable myDog. We create an instance myDog with Willy and 6 age old. And we can create another dog called your dog, named Lucy and 3 years old. Then we can access attributes. To access the attributes of an instance, you use dot notation. So we can get the name and age of my dog using my dog.name and my dog.age. For example, we can print a message using my dog's.names title4 and print a message of my dog's.8 years old. You can print a message. So my dog's name is Willie. Then print message using the attribute of age. My dog is 6 years old. And we can also print your dog's. So your dog's name is Lucy. And print using your dog's age attribute. Your dog is 3 years old. And we can also call methods. Method actually is the function. So we can also use dot notation to call my methods defined in dog. So let's make our dog sit and roll over. So my dog.sit. My dog is an instance because this instance belongs to a class dog, and the dog class has sit method, sit function. So we can use dot notation. So my dog.sit. So we call this function. Similarly, we can use my dog.rollover. So rollover this function will be called. My dog sit. So Willie is now sitting. My dog.rollover. So Willie is now rolling over. And your dog can also sit. Lucy is now sitting. Of course, your dog can also roll over. So let's write a new class representing a car. Our class will store information about the kind of car we are working with, and it will have a method that summarizes this information. So we defined initial method with the self parameter first. We also give 3 other parameters: make, model, and year. A method called getDescriptiveName that puts a car's year, make, and model into one string neatly describing the car. Then we make an instance from the car class and store it in the variable myNewCar. Then we call getDescriptiveName to show what kind of car we have. So this is a class for car, capitalized class for car. And inside the class definition is an initial method with self first, then 3 parameters: make, model, year. With the information, when we calling this, when we make an instance of this car, we will put and input this information. Then for this initial method, we'll pass these 3 information to the attribute of this car called make, model, and year. Then a method called getDescriptiveName with the parameter self will create a variable called longName, which concatenates the information of year, make, and model together. Then we'll return these names title4. So next we can make an instance of this car class called myNewCar with 3 information for make, model, and year. And we can also call this method getDescriptiveName for myNewCar. So we see create this class. Okay, we can wait. There are lots of other methods. We can also set a default value for an attribute. So every attribute in a class needs an initial value, even if that value is 0 or an empty string. So in some cases, such as when setting a default value, if you do this for an attribute, you don't have to include a parameter for that attribute. So let's add an attribute called odometer reading that always starts with a value of 0. So inside the initial method, we can create another attribute called odometer reading. Odometer reading, but with the initial value 0. So in this function, initial function, we do not need other information for this attribute, which means when we call this class to make an instance, we do not need to add odometer reading when we make an instance of this class. So you can see class definition, initial method with make module year coming from the instance information, but odometer reading with an initial value 0. Then this is the function for get descriptive name. Then we also add a method called read odometer that help us read each class odometer. So read odometer function with self as parameter will print this class odometer reading attribute in the message. So when we have this instance called myNewCar, we can use this method with dot notation myNewCar.read odometer. So calling method read odometer will read a class current mileage. So we can this function define read odometer self, then we print out this class odometer reading attribute in the message. And we can also modify attribute values. You can change an attribute values in 3 ways. You can change the value directly through an instance, set the value through a method, or increment the value, add a certain amount to it through a method. So modifying an attribute value directly, the simplest way to modify the value of an attribute is to access the attribute directly through the dot notation of an instance. So here we set the odometer reading to 23. Because the odometer reading's initial value for each car is 0, so now we can modify this reading use this way. We can use myNewCar.odometer reading is 23. So next we use myNewCar.read odometer will get this new value. We will try this. We create this car class. Then create an instance of this car with all the A4 and the 2016 year. Then we can print descriptive names information. This method is dot notation. The dot notation for this car's information. Then we can read odometer. So initial value is 0, so this car has 0 miles on it. And we can also make odometer reading, modify the odometer reading directly using dot notation. So we can read odometer reading again now. So this car has 23,500 miles now. So you can also modify an attribute value through a method. So instead of accessing the attribute directly, you can pass the new value to a method that handles the updating internally. Here is an example showing a method called update odometer. So we can also write a method called update odometer with 2 parameters. First is self for this car, then the miles. So next, int function definition of update odometer. You can write self.odometer reading. Self is this car, dot odometer reading is this attribute, then equals the miles we passing for this function with the new value. So next, when we make an instance called my used car, post car, put in 3 information, make model year, then we can update this automated reading to a new value, use the dot notation of my used car dot update automate with new value. Then we can read automate again. So should we create an instance of this car, Subaru Outback 2013. So then print the get information name of this car dot notation. So the information is printed out 2013 Subaru Outback. Next, we can update the automated reading of this car to 23,500. Use this method. Then we can read automate reading. So this car has 23,500 miles on it. So we can extend the method update automate to do additional work. Every time the automated reading is modified, let's add a little logic to make sure no one tries to roll back the automated reading. So we can define update automate self miles with inside the function with if statement. So if miles larger than the current automated reading, then we assign these new miles to the automated reading. So if this conditional test is not true, which means the miles is less than the current automated reading, we will not assign these new miles to the automated reading. We will print a message: you cannot roll back an automate. So this is the function for update automate reading in the class definition. So only the miles larger than the current automated reading we can update with this value. So for example, when we try my used car dot update automate with 20,000, you will get a message you can't roll back in automate because current value is 23,500. So 20,000 is less than this current value. So incrementing an attribute value through a method. So sometimes you will want to increment an attribute value by a certain amount rather than set an entirely new value. Say we buy a used car and put 100 miles on it between the time we buy it and the time we register it. Here is a method that allows us to pass this incremental amount and add that value to the automated reading. We can define a function called increment automate, with self is the car and miles is increment the value with 2 parameters. So inside the function, we can write self means that this car dot automated reading plus equal means automated readings attribute of this car will be incremented with this value miles, which have been passed for the function. So when we create this instance called my used car of car class with the information Subaru Outback 2013, we can use a function, use dot notation with my used car dot increment automate this function, and with input value was 100. So then the car's automated reading will be incremented with 100 miles upon the current value. Then we can also read automated reading. So we'll try create an instance first called my used car. Then we print out the information of this car. Then we read automate of this car is 0 miles now. Then we can update this car's automated reading. Then we read automated reading again. 23,500 now. Then we increment automate with 100. Then we read again this car. Now has 23,600 miles on it. Inheritance of classes. The inheritance, you don't always have to start from scratch when writing a class. If the class you're writing is a specialized version of another class you wrote, you can use inheritance. So when one class inherits from another, it automatically takes on all the attributes and methods of the first class. The original class is called the parent class, and the new class is the child class. The child class inherits every attribute and method from its parent class, but is also free to define new attributes and methods of its own. So, the initial method for a child class. The first task Python has when creating an instance from a child class is to assign values to all attributes in the parent class. To do this, the initial method for a child class needs help from its parent class. So as an example, let's model an electric car. An electric car is just a special kind of car, so we can base our new electric car class on the car class we wrote earlier. Then we will only have to write code for attributes and behavior specific to electric cars. So let's start by making a simple version of the electric car class which does everything the car class does. So this is the car class, part of the car class called is a parent class in this case. We have seen car class with 3 input information for make, model, year when you create an instance of this class, and inside the initial method we also define automated reading with beginning value 0, and there are several methods. We only show 2 methods here. For example, get descriptive name of this class information, and can read automate for this class automate information. So making a simple version of the electrical car class which inherits from parent class car, then we can define an electrical car class like this. So inside the electrical car class, the parameter we have to write car class, which means electrical car class inherits from car class. And in definition of initial function, we also write self, make, model, year, the same as the parent class. But the definition of this function, we have to write sup.initial. Sup means the parent class, so which means the definition of these variables, attributes for the electrical car class is based on the definition of these attributes in car class. So when we call or make instance of electric class, we can just write electric car, then with the information Tesla Model S 2016, and we can also use the method, for example, get descriptive name, same as we using this function method for a normal car. So when you create a child class, the parent class must be part of the current class and must appear before the child class in the file. So we define the child class electrical car, and the name of the parent class car must be included in parentheses in the definition of the child class. And the initial method for a child class. The initial method takes in the information required to make a car instance, and the super function is a special function that helps Python make connections between the parent and the child class. This line tells Python to call the initial method from electrical car class's parent class, which gives an electrical car instance all the attributes of its parent class. And we make an instance of the electrical car class with the same kind of information we had provided when making a regular car, and store it in my Tesla. the initial method defined in electrical car, which in turn tells Python to call initial method defined in the parent car class. So let's see. Because we have to create the car class before this line, so we can create an electrical car class now. So electrical car, and in the parentheses is a car class. So this means electrical car class is inherited from car class. Okay, so initial method self module make year, and super have to write a super dot initial make module year. Then we can call and make an instance of electrical car now with Tesla Model S 2016. Then we can use this method which defined in the parent class. So get descriptive name. Although we do not need to create this function in electrical car class definition because we inherit from car class, and the car class has this method defined in car class definition. So we can use this. The information is 2016 Tesla Model S. Working with attributes and methods for the child class. So defining attributes and methods for the child class. So once you have a child class that inherits from a parent class, you can add any new attributes and methods necessary to differentiate the child class from the parent class. So let's add an attribute that's specific to electrical car, a battery, for example, and a method to report on this attribute. And we will store the battery size and write a method that prints a description of the battery. This attribute will be associated with all instances created from the electrical car class, but won't be associated with any instance of car. We create the electrical car inherits from car class. Then inside its definition of initial function, in addition to make module year, which inherits from the soup of which means from a car class, then we define using self here the battery size attribute. So this attribute is only applied to electrical car class with a 70 initial value. Next, we define a function called describe battery with self, which means this function only applies to electrical car also. Then we print out this electrical car's batteries information in message. So next we can create an instance of electrical car with these three information. Then we can print, and to call this function get descriptive name. Then next we can call this method called describe battery, which can get the battery's information of this electric car. We create this first. Create this electric car class. Then make an instance now. Then can print out car's information. Then we can also call the describe battery function of this car. So this car has a 70 kWh battery. So overriding methods from the parent class. So you can override any method from the parent class that doesn't fit what you are trying to model with the child class. To do this, you can define a method in the child class with the same name as the method you want to override in the parent class. So Python will disregard the parent class method and only pay attention to the method you define in the child class. say the class car, the parent class, the method called fuel gas tank. And this method is meaningless for an all-electric vehicle, so you might want to override this method. So here is one way to do that. You can define a function with the same name in class electric car here and print a message for this function's definition. Then, if for the electric car instance, when you call this function, then the information will be printed out like this, and instance as attributes. So when modeling something from the real world in code, you may find that you are adding more and more detail to a car. You will find that you have a growing list of attributes and methods, and that your files are becoming lengthy. In this situation, you might recognize that parts of one class can be written as a separate class. So you can break your large class into smaller classes that work together. For example, if we continue adding details to the electric car class, we might notice that we are adding many attributes and methods specific to the car's battery. So when we see this happening, we can stop and move those attributes and methods to a separate class called battery. Then we can use a battery instance as an attribute in the electrical car class. So what this means, you can see, you can create a battery class. There are lots of information associated with this battery class. So first, define initial method function for this battery class. So there's an attribute called battery size created, and battery size initial value is 60. Then we can describe this battery function created, then show the battery size. You can also define a function called getRange. GetRange. So if battery size is 60, the range is 140. So if the size is 55, the range is 155. Then we can print out the message of the range of this battery. So this is a battery class with battery size as attribute and two functions. Then next we can create an electric car class inside the initial function definition. In addition to this make, model, year information, we can add an attribute battery, but this time the attribute's value is the instance of battery class now. So this electric car class has attribute make, model, year, and battery. And make, model, year are the information we input when we make an instance of electric car. But the battery is an instance of the battery class. So next, when we make instance of electric car, we can print information of this car. Then we can use this car's attribute battery to describe a battery function. We can also call this car's battery's attributes getRange function. These two functions defined in class battery in the previous page. So in the electric car class, we now add an attribute called battery. This line tells Python to create a new instance of battery with a default size of 60, because we are not specifying a value, and store that instance in the attribute battery. This will happen every time the initial method is called, and the electric car instance will now have a battery instance created automatically. Then we create an electric car and store it in the variable myTesla. But when we want to describe the battery, we need to work with the car's battery attribute and methods. So these two lines use dot notation. myTesla's battery dot describe battery is a function defined in class battery. Similarly, myTesla.battery dot getRange, this function defined in class battery. So we show this, create a class called battery. Then create a class, and attribute battery will be the instance of battery class. Then after this class has been created, we can make instance of electrical car. Then we show this class name information. Then we describe battery, show this class battery information, and we'll get a range information of this electrical car. The car has approximately 140 miles on a full charge. Importing classes. As you add more functionality to your classes, your files can get long, even when you use inheritance properly. In keeping with the overall philosophy of Python, you will want to keep your files as uncluttered as possible. To help, Python lets you store classes in modules and then import the class you need into your main program. So we can, for example, import a single class. Let's create a module containing just a car class. This module file will be named car.py, and the car class is stored in this module file. The module file car.py is put in the same directory of your working source file. So this is part of the file, module file car.py. Inside this file is a class definition for car, which we have introduced in the previous lectures. Then in your working source file, you can import car from module. So this car is a class from module car.py. So from car, import a car. So this is the file name without the .py. The file name, module name, then import this class. So next we can make an instance of this car, and we can also print out this instance's descriptive information. We can also add automated reading for the function automated reading attribute to this car with 23, then use the function of this car to read automate. So we first set a working directory because this file called car.py stored in this working directory. Next we import from this car module, import this car class. Then can create an instance of the car class. We can print out descriptive information of this car. Then we can set automated reading attribute of this car to 23. Then we can call this function read automate of this car. So this car has 23 miles on it. We can also store multiple classes in a module, so you can store as many classes as you need in a single module file, although each class in a module should be related somehow. The class battery and electrical car both help represent cars, so let's add them to the module car.py. So in the file car.py we add class battery also, which we have introduced in the previous lectures. And for the battery class, we also has getRange, for example, getRange function, and we also store electrical car class in this file car.py. So when you import multiple classes from a module, you can use from car import car class, then comma electrical car class. So next in our program we can make instance from car, or we can make instance from electrical car, and we can also print out attributes or information of this car and attribution of this electrical car. So we see can import electrical car from this car module. Can create an instance and print out descriptive information of this electric car, and we can print out descriptive battery of this electric car. We can also run this, call this function getRange of the battery attribute of this car. So import multiple class from this module. Then we can create a normal car with information Volkswagen Beetle 2016. Then print out descriptive information of this car. Then we can create an electric car instance called My Tesla. We can print out name information, model information of this car. So we can also import an entire module. So you can import a car. This is a car's file name, module name. So import a car. Next, when we create instance of car class, we have to write car dot this car class. So this is a module name. This dot notation dot class name with information. Similarly, we can create an electrical car. Use car is the module name dot electrical car is the class name, and we can also show the information. So we import. This time we import the whole entire module. Import car. Then we can create a normal car instance. Use the car dot car class, and you can print out the descriptive name information of this car. And we can also create an electrical car. Use the car dot notation electrical car. And print out information of this electrical car. Reading from a file. So when you want to work with the information in a text file, the first step is to read the file into memory. You can read the entire contents of a file, or you can work through the file one line at a time. So reading an entire file. So let's start with a file saved in the same working directory, such as contains pi to 30 decimal places with 10 decimal places per line. So this file is the pi digits like this, stored in this txt file. And the following code opens this file, reads it, and prints the contents of the file to the screen. So start with a then with open this file as a file object. Then inside this block, with block, we write contents is this object dot read function. Then we can print contents, and the result will be like this. So we first set working directory. Then we read this file. Use with open this file as file object. Then contents is this object to read. Then print this information, but we use strip here. We will talk about it later. So output like this. And the open function returns an object representing the file. The read method then reads the entire contents of the file and stores it as one long string in variable contents. Notice close is not needed because Python will close it automatically when the time is right. And the only difference between this output and original file is the extra blank line at the end of the output. The blank line appears because read returns an empty string when it reaches the end of the file. and this empty string shows up as a blank line. So if you want to remove the extra blank line, you can use rstrip in the print statement. So that's why we use rstrip here. Rstrip here because we want to remove this blank line in the reading. The file path. Sometimes, depending on how you organize your work, the file you want to work won't be in the same directory as your program file. To get Python to open files from a directory other than the one where your program file is stored, you need to provide a file path which tells Python to look in a specific location on your system. So we use a relative file path can tell Python to look for a given location relative to the directory where the currently running program file is stored. So on Linux and OS X system, you have to write, for example, with open test. Test is a directory relative to your current working file. Then the file stored in this directory as open as file object. On Windows system, you use a double backslash instead of a forward slash in the file path. You can use with open test to double backslash, then this file name as file object. So now the file is stored in the test location relative to this working file. So we can run this because we use a Windows system. So with open this file as file object and can then read this file and print out. It also works. And you can also use an absolute file path to tell Python exactly where the file is on your computer regardless of where the program that's being executed is stored. So on Linux and OS system, you can use like this for the absolute path. And on Windows, can use, for example, the Python beginning course and a test with this file. So I try to use absolute path. So file path create first as absolute path a string. And we can open this file as file object, then read file and print. Also works. And read line by line. You can use a for loop on the file object to examine each line from a file one at a time. For example, this is file name. You can open this file, then inside the with block, write a for loop. For line in file object, then print this line. Read line by line. File path first. Then with open this file, then read line by line. For line in object, print this line. So every line is printed out. And these blank lines appear because an invisible new line character is at the end of each line in the text file. The print statement adds its own new line each time we call it, so we end up with two new line characters at the end of each line, one from the file and one from the print statement. So we can use rstrip on each line in the print statement to eliminate these extra blank lines. So we can use rstrip here also to remove the extra blank line. Rstrip here this time. So now it's much better. Make a list of lines from a file. So when you use with, the file object returned by open is only available inside the with block that contains it. So if you want to retain access to a file's content outside the with block, you can store the file's lines in a list inside the block, and then you can work with that list later. And the following example stores the lines of pi-digit text in a list inside the with block, and then prints the lines outside the with block. So we can read this file with block, then use read lines and save these lines to a list called lines. Then outside of the with block, we can next print out each line with a for loop. So first, this is the file name. Then we use a with block to read the lines, then save to the lines. This lines is a list. Then next, outside of the with block, we can use a for loop to read each lines and print out. Working with the file's contents, after you have read the file into memory, you can do whatever you want with that data. So let's briefly explore the digits of pi. First, we will attempt to build a single string containing all the digits in the file with no white space in it. So file name, then we open this file, then read the lines and store back to the lines list. Next, we can create an empty string called pi string. Then for lines this list, we will use concatenate with odd lines with this string. Then print out a long string. Next, we can print out the length of this string. So file name, name, then read the lines and store to this list lines, each line. Next, pi string is not a space string. Then for each line, we can take this lines string, then use rstrip, then concatenate the to pi string. Then we print out this long string. And we print out the length of this string. 36 elements. And the variable pi string contains the white space that was on the left side of the digits in each line, but we can get out that by using the strip instead of rstrip. So here we use strip. Strip can get the white space on the left side also. File name, read lines, but use strip this time. Then print pi string. So it is a long string without white space. Then length of this string 32 now. And the larger files, 1 million digits, the code in previous example would work just as well on much larger files. If we start with a text file that contains pi to 1 million decimal place instead of just 30, we can create a single string containing all these digits. We'll print just the first 50 decimal place. The file this time the file name is pi million digits. We open this file and read the lines. Then we create a pi string, empty string. Then for each line, we will concatenate all the strings for each line. Then we will print out the first 52 decimal place of this string. And we will print the length of all the string. So this file name. Then with open, we read this file for each line to a list. Then create an empty string. Then for each line, we get the string out and concatenate it together. But with the strip for to remove the white space. Then we print out the first 50 decimal places for this long string. And we print the length of the whole string. 1,000,002 because 1,000,000 decimal place. So next we can test, is your birthday contained in pi, this string? So let's use the program we just wrote to find out if someone's birthday appears anywhere in the first 1,000,000 digits of pi. We can do this by expressing each birthday as a string of digits and seeing if that string appears anywhere in pi string. So we can use the input for user to input your birthday. Then we test if birthday in pi string will print out this message. If birthday not appear in the pi string, we'll print another message. So create and read is the same as before. Then next we can let the user to enter birthday. For example, okay, birthday. Then is your birthday in string, and if not in string, we'll get a message. Your birthday appears in the first 1,000,000 digits of pi. So this birthday appears in the first 1,000,000 digits of pi. Write into a file. To write a text to a file, you need to call open with a second argument, telling Python that you want to write to the file. To see how this works, let's write a simple message and store it in a file instead of printing it to the screen. So first, we set a file name in the working directory. Then we open this file with W mode, write mode as file object. Then we can write file object.write this message inside this with block. So the argument W tells Python that we want to open the file in write mode. You can open a file in read mode with R, write mode with W, and append mode with A. One mode that allows you to read and write to the file with R+. If you omit the mode argument, Python opens the file in read-only mode by default. So we set the file name. Then we open this file with the write mode, then write a message. Then we open this file in the working directory, create it. Put the message in this file now. The open function automatically creates the file you are writing to if it doesn't already exist. However, be careful opening a file in write mode W, because if the file doesn't exist, Python will erase the file before returning the file object. Python can only write strings to a text file. If you want to store numerical data in a text file, you will have to convert the data to string format first using the str function. So we can also write multiple lines. The write function doesn't add any new lines to the text you write. So if you write more than one line without including new line character, so including new lines in your write statement. For example, we write this file again. We open this file with the write mode. Then first we write this message. Then we add a new line. Then we write next message, new line. We try this. In this file, then write 2 lines message. Then we open this file. Now there are 2 lines message in this file now. And we can also append to a file. If you want to add content to a file instead of writing over existing content, you can open the file in append mode. Let's modify this file by adding some new reasons why we love programming to the existing file programming txt, so file name. Then open this file with append mode. So we write 2 more lines in this file. Try this. We open this file to the same file with append mode. Then write 2 message. Then we see this file again. So now there are 4 lines in this file. So 2 lines appended to the first 2 lines. Introducing try except blocks exception. Try except blocks. Python uses special objects called exceptions to manage errors that arise during a program's execution. Whenever an error occurs that makes Python unsure what to do next, it creates an exception object. If you write code that handles the exception, the program will continue running. If you do not handle the exception, the program will halt and show a traceback, which includes a report of the exception that was raised. Exceptions are handled with try except blocks. A try except block tells Python what to do if an exception is raised. So when you use try except blocks, your programs will continue running even if things start to go wrong. Instead of traceback, which can be confusing for users to read, users will see friendly error messages that you write. So, for example, we're handling the 0 division error exception. So let's look at a simple error that caused Python to raise an exception. You probably know that it is impossible to divide a number by 0, but let's ask Python to try it first. So if we print 5 divided by 0, there will show an error. Print 5 divided by 0. So there will be an error called 0 division error. But the error reported in the traceback 0 division error is an exception object. Python creates this kind of object in response to a situation where it cannot do what we ask it to. So when this happens, Python stops the program and tells us the kind of exception that was raised. So we can use this information to modify our program. We will tell Python what to do when this kind of exception occurs. Here is what a try except block for handling the 0 division error exception looks like. So we can use a try except block for handle this error. First, we will try this statement. Then we will see except if 0 division error occurs, then we check except if the error happens, then except block will check if it is 0 division error. If this matches, then the statement inside except block will run. So we put print 50, the line that causes the error, inside the try block. If the code in a try block works, Python skips over the except block. And if the code in the try block causes an error, Python will look for an except block whose error matches the one that was raised and runs the code in that block. So in this example, the code in the try block produces a 0 division error. So Python looks for an except block and telling it how to respond. So Python then runs the code in that block and the user sees a friendly error message instead of a traceback. So we try print this one, then check except 0 division error. We run. So the message has been printed out. So except the block is run. We can use try except else to prevent crashes. So in some cases, we can use try except else block, handling errors smoothly when the program has more work to do after the error occurs. This happens often in programs that prompt users for input. If the program responds to invalid input abruptly, it can prompt for more valid input instead of crashing. So let's create a simple calculate that does only division. We can make this program more error resistant by wrapping the lines that might produce errors in try except else block. So the error occurs on the lines that performs the division, so that's where we will put the try except block. And this example also includes an else block. So any code that depends on the try block executing successfully will go in the else block. We print a message, then print another message, then if while true, let the user to input first number. If user input first number equals to Q, then the while loop will break. Then second number is also an input by user. Next, we'll run a try except else block. So in the try is division between int value of int value first number divided by int value of second number. So if this statement runs successfully, then the else block will run. Print this answer. If it raise an error except block object, then Python will check except statement if this error is zero division error. So then we'll print if matches this error, then we'll print you cannot divide by 0. So we should first we print the two messages on the screen. Then we will run this while true, while loop. So let user to input first number and second number. If user in the first number enters Q, then the while block running will stop. And if user enters 0 in the second number, then the error will come and will print out this message. If both number cause the division runs successfully, then we print answer. First number 10, second number 5. Then the answer printed and while loop runs again. First number 100, second number 3 also runs successfully. Then first number 19, second number 0. Then you can't divide by 0. Message is printed out. Then the while loop is not stopped. You can also try next. First number, for example, write Q, then stopped while loop. So handling the file not found error exception. So one common issue when working with files is handling missing files. The file you are looking for might be in a different location. The file name may be misspelled, or the file may not exist at all. You can handle all of these situations in a straightforward way with a try except block. So let's try to read a file that doesn't exist. The following program tries to read in the content of Alice in Wonderland, but file Alice1 text has not been saved in the same directory as the current working source file. So we try to read this file, but this file does not exist. We'll see how it happens. So file is alice1.txt. We open this file, then try to read this file. The file not found error happens. So Python cannot read the file from a missing file, so it raises an exception. No such file or directory. So to handle it, you can use a try block that will begin just before the line that contains open to look for and accept blocks that matches that error, and the result is a friendly error message instead of a traceback. We can change with the try except block, then open this file, then read. So if this block successful, the except block will be skipped. And if try block raise an exception object with error, so the except block will be checked if the error matches file not found error. If it matches, then the message and this block will be run. So the code in the try block produces a file not found error. So Python looks for an except block that matches that error. Python then runs the code in that block, and the result is a friendly error message instead of a traceback. So we try this file name. Then use try except block. So now the message is run. The file, this text does not exist. So we can also analyze text using try except else block. So for example, you can analyze text files containing entire books. The texts used in the following example come from Project Gutenberg, which maintains a collection of literary works that are available in the public domain. Now let's pull in the text of Alice in Wonderland and try to count the number of words in the text. We will use the string method split, which can build a list of words from a string, then count the items in the list to get a rough idea of the number of words in the text. So this is the file we want to work with, and we write try to read this file. If it's not successful, then except block will be implemented to check if the error is file not found error. And we'll run this message if it matches. If try block successful, then the else block will be run. We'll split the text first, then count the words, then print out the message how many words this book has. We try this. Alice, this book, then try except else block to read and count the words. So to run successfully, this text has about 29,000 words. And we can also create a function holding the whole try except else block. You can move the try except else block to a function called count words. So it will be easier to run the analysis for multiple books. And the missing this file has no effect on the rest of the program execution. So we can create a function. The function actually we put the previous page's try except else block in this function called count words. Then next we can try to read several books using a for loop and count words. In the working directory, we have these 4 books. So we run this function first. Count words, create this function. Then we create a list with 4 books inside. And we intentionally write a wrong name for this book, Cinderella. Actually, the book is called Cinderella.txt, but we add 1 here to see how it is going with this file. So next is a for loop to call this function for each of these 4 books. So you can see the file Alice text has about 29,000. It's okay. But for the second book, Cinderella, the file Cinderella.txt not exist. And the next 2 books also works and count the words. So there's quite a friendly message and smoothing working running for the program with try except else block. Using try except else pass and finally in Python. So let's first review how the try and except works. First, the try clause is executed. If there is no exception, then only try clause will run, except clause will not get executed. If any exception occurs, the try clause will be skipped and except clause will be checked. If any exception occurs and matches the except statement, the except block will run. If the exception does not match the except, then the execution stops. A try statement can have more than one except clause. And using try, except, else, and finally in Python. So try, this block will raise an exception if there is an error. Except here you can handle the error if it matches. An else block runs only if the try clause does not raise an exception. Finally block always gets executed either exception is generated or not. So we see an example called division x by y. It's a function called division x by y. Say inside the function, first try this division, then if this has error, then we'll check the except block if it is zero division error. If it matches, then you will show the message you are dividing by 0. And if try block has no error, then the else block will be run. And finally block will always be run either there is an exception object raised or try block successfully run. So we try to do this, divide 3 by 2 and 3 by 0. This is called floor division. See, create this function, then try to run this. 3 by 2, the answer is 1, and this always executed. So finally block also run, and the answer is run. So answer is run, else block is run because there is no error in the try block. If we try to divide 3 by 0, the message is sorry, you are dividing by 0. So except block is run, and this is always executed. So finally block is also run. And we can also let it fail silently. So sometimes you will want the program to fail silently when an exception occurs and continue on as if nothing happened. To make a program fail silently, you write a try block as usual, but you explicitly tell Python to do nothing in the except block using a pass statement. So else blocks runs only if the try clause does not raise an exception, and the finally block always gets executed either exception is generated or not. So this is the pass function. So we changed this function called count words in the previous lectures. Count the words of text. So inside this function, the try to read this book. Then int except block if the error is found not found error, and we pass here. Then in the else block, we count the words and print out the message. So we should first create this count words function. Then we create a list of 4 books, but with this name intentionally add 1 here. So this book does not exist in the working directory. Then in a for loop to read each book and count words. So you can see the first book has about 29,000 words working correctly. The second book, because it's not found, so Python runs silently, does not show any information about this book. The next 2 books implementation work correctly. Numpy is a basic package for scientific computing with Python and especially for data analysis. In fact, this library is the basis of a large amount of mathematical and scientific Python packages, and among them the pandas library, which is specialized for data analysis and fully developed using the concepts introduced by Numpy. And in fact, the building tools provided by the standard Python library could be too simple or inadequate for most of the calculations in data analysis. So having knowledge of the Numpy library is important to being able to use all scientific Python packages, and particularly to use and understand the pandas library. Numpy is currently the most widely used package for the calculation of multi-dimensional arrays and large arrays. In addition, the package comes with a range of functions that allow you to perform operations on arrays in a highly efficient way and perform high-level mathematical calculations. So installation and import of Numpy. Generally, this model is present as a basic package in most Python distributions. However, if not, you can install it later. In Anaconda prompt, you can install Numpy by printing conda install Numpy. Once Numpy is installed on your distribution, to import the Numpy module within your Python sessions, for example like Anaconda Spider, you can write the following: import Numpy as np. So we can import Numpy. ndarray, the heart of the Numpy. The Numpy library is based on one main object called ndarray, which stands for n-dimensional array. This object is a multi-dimensional homogeneous array with a predetermined number of items. Homogeneous because virtually all the items in it are of the same type and the same size. In fact, the data type is specified by another Numpy object called dtype. So each ndarray is associated with only one type of dtype, and the number of the dimensions and items in an array is defined by its shape, a tuple of n positive integers that specifies the size for each dimension. The dimensions are defined as axes and the number of axes as a rank. Moreover, another peculiarity of Numpy arrays is that their size is fixed, that is, once you define their size at the time of creation, it remains unchanged. And this behavior is different from Python lists, which can grow or shrink in size. So the easiest way to define a new ndarray is to use the array function, passing a Python list containing the elements to be included in it as an argument. So we can create an array using np.array 1, 2, 3 and a list. So A will be an array with 3 elements. So we can create this array, one-dimensional array with 3 elements. And we show this array 1, 2, 3. And you can easily check that a newly created object is an ndarray by passing the new variable to the type function, type A. So we can show type A is a Numpy's ndarray. And you can, in order to associate the type dtype to the newly created ndarray, you have to use the dtype attribute. So we can use the dtype attribute to this array. Dtype, the dtype int 32. It is integer type with 32 bits. And the just created array has one axis, and then its rank is 1. So while its shape should be 3, 1. To obtain these values from the corresponding array, it is sufficient to use the ndim attribute for getting the axis, the size attribute to note array length, and the shape attribute to get its shape. So if we use ndim to this array, only one, so one-dimensional a.size three elements, and a.shape 3, so one dimension, the first dimension has 3 elements. And define a two-dimensional array. We can also define a two-dimensional array using toListInt np array function. So we can also show dtype, ndim, size, and shape. Two-dimensional array. And dtype is float number 64 bits. The ndim dimension is 2 now. And the size is 4, because two dimension, each dimension has 2 numbers, so total elements is 4. B.shape 2 by 2, the shape is 2 by 2. To create a new array, you can follow different paths. The most common path is the one through a list or sequence of lists as argument to the array function. So we create a two-dimensional array with adding toListInt np.array function. And the array function, in addition to lists, can accept the tuples and a sequence of tuples. So we can also add two tuple in the np.array function, or we can add combined tuple and list in the function. First, create function with adding two lists, and we show this ndarray two-dimensional, and can create array using two tuples. Get the same result as using lists. Can also create array using combined list and tuple. Also a two-dimensional array. Dtype. So Numpy arrays are designed to contain a wide variety of data types. We have seen simple integer and float numerical values. In addition, you can use the dtype for strings. So we create an array, two-dimensional array with the value of strings in the list. So dtype will like u1, less than u1, and have also a name attribute for the dtype. Create this tuple using the string layer of list. Then the dtype u1, and the dtype has a name attribute, string 32. By default, the ndarray function can associate the most suitable type according to the values contained in the sequence of lists or tuples. Actually, you can explicitly define the dtype using the dtype option as argument of the function. For example, if you want to define an array with complex values, you can use the dtype option as follows. So if we add the dtype equals complex, so these numbers will be stored as complex number in the array. So create this array. So complex number now stored in the array. The Numpy library provides a set of functions that generate ndarrays with initial content created with different values depending on the function. The zeros function, for example, creates a full array of zeros with dimensions defined by the shape argument, while the ones function creates an array full of ones in a very similar way. So if we write np.033, a two-dimensional array of 3, and all the values are 0, and similarly write a three-dimensional array of the shape 2 by 3 by 4 with all the values are 1. And np.arrange010 will create a sequence of values between 0 and 10. And arrange 4, 10. So we'll create a sequence of numbers starting from 4 to 10. So np zeros 3 by 3, the shape all values 0 and ones, all values are 1, 3-dimensional, and sequence number using arrange. So number 0 to 9 created in array, arrange 4 to 10. So the number 4 to 9 created in this array. And you can also use the gap not equals 1. So here you create a sequence number between 0 and 12 with the gap 3. And this is the gap 0.6. Create number array 0369 now. And this array with the gap 0.6. So from 0 to 5.4. And you can also generate two-dimensional arrays using arrange and reshape. So we create a sequence number first from 0 to 12, then reshape to a two-dimensional array with the shape 3 by 4. So the two-dimensional array is the number from 0 to 11. The shape is 3 by 4. And line space generates a sequence of numbers based on the number of elements in a third argument. So np.linespace 0, 10, 5 means to create an array with 5 values equally distanced between 0 and 10. np linespace 0, 10 with 5. So this is the resulting array with 5 numbers equally distanced between 0 and 10. Just note, in arrange function, the 10 is not included, but in line space, the 10 is included. And np.random will generate random float numbers in the interval between 0 and 1. So we can write np.random3 will generate 3 random numbers between 0 and 1, and np.random 3 by 3 will generate two-dimensional array with random numbers between 0 and 1. np.random3, so 3 random numbers in a one-dimensional array. So this will create two-dimensional array with a shape 3 by 3 with all the values and random numbers between 0 and 1. Arithmetic operators. The most obvious are adding and multiplying an array by a scalar, and these operations are element-wise, such as the operators are applied only between corresponding elements. So this is a Numpy array with the number from 0 to 3. Then we can add a with 4 or multiply a with 2. Numpy array. So a 0 to 3. then a plus 4 will return another Numpy array with the elements 4, 5, 6, 7. A multiply 2, so each element will be multiplied with 2 in the new array. And can create another array B with also 4 elements, then A can plus B or A multiply B. So B is an array with elements 4, 5, 6, 7, then A plus B. So element-wise addition between A and B will return another array with 4 elements. A multiply B will get also another 4 element array with each element is the multiplication between the corresponding elements in A and B. And moreover, these operators are also available for functions provided that the value returned is a Numpy array. So for example, you can multiply the array by the sum or the square root of the elements of array B, and they are also element-wise. So assume A and B here have the same shape. So we can A multiply Numpy sum function of B, or A multiply the square root of B. A multiply the sum function of B, and the result is also a Numpy array with 4 elements. A can multiply the square root of B. Also, the result is a 4-element Numpy array. And for multidimensional case, arithmetic operators continue to operate element-wise. So this is a 2-dimensional Numpy array with shape 3 by 3, and B is also a 3 by 3 shape 2-dimensional Numpy array with elements all equals 1. Then A can multiply B element-wise. So create A first. A is a 2-dimensional array, and B also 2-dimensional array. Then A multiply B element-wise a 2-dimensional array. And actually the value of each element in the resulting Numpy array is same as in A, because B, all elements in B is 1. The matrix product in Numpy array, the matrix product is indicated by the dot function. This operation is not element-wise, that is, the result at each position is the sum of the products of each element of the corresponding row of the first matrix with the corresponding element of the corresponding column of the second matrix. So Numpy dot A and B is the matrix production A multiply B. You see, so this is the result of matrix multiplication A and B. An alternative way to write the matrix product is to take dot function as an object function of one of the two matrices. So we can also write Numpy dot A and B. Also, A is the first matrix, B is the second one. Or A dot B. So these two is the same. Note that since the matrix product is not a commutative operation, the order of the operands is important. So indeed, A multiply B is not equal to B multiply A in the matrix multiplication. So also show A dot B the same results as this one, but we should numpy dot b and a is not the same. And increment and decrement operators. To increase or decrease values, we have to use operators such as plus equal or minus equal or multiplication equal. Instead of creating a new array with the results, they will reassign the results to the same array. So we can write a plus equals 1. Then the array of a, each element will be added with 1. And similarly, a minus equal 4, each element of array a will be minused with 4. And this will multiply with 4 for each element in a. We create array called a 0, 1, 2, 3. Then a plus equal 1. We show again each element has been added with 1. A minus equal 1. We show again a then the value is being changed back. We can also create a 0, 1, 2, 3, a, for example, plus 4, change it to 4, 5, 6, 7, and multiplication to 8, 10, 12, 14 now. And universal functions. A universal function, generally called ufunc, is a function operation on an array in an element-by-element fashion. And this means that it acts individually on each single element of the input array to generate a corresponding result in a new output array. So in the end, we obtain an array of the same size as the input. There are many mathematical and trigonometric operations that meet this definition. For example, calculating the square root with the square root, the logarithm with the log, or the sum function with the sum. So a is an array, can calculate the square root of a, log a, and sum. Create a is an array, then square root of a for each element, then logarithm of a. Result is also a 4-element array, and sum function of a. Aggregate function. Aggregate functions perform an operation on a set of values of an array, for example, and produce a single result. So many functions of this kind are implemented within the class ndarray. For example, a is an 5-element array, that we can calculate the sum of a, minimum, maximum of a, and mean value of a, or standard deviation of a. Then a dot sum, summation, the minimum value of a, maximum value of a, and the mean or average value of a, and the standard deviation of a. Indexing. Array indexing always use square brackets to index the elements of the array so that the elements can then be referred individually, or various uses such as extracting a value, selecting items, or even assigning a new value. So when you create a new array, an appropriate scale index is also automatically created. In order to access a single element of an array, you can refer to its index. So this is an array created with 6 numbers from 10 to 15. So we can write a bracket 4. Then the 5th element of this array will be selected. So create an array first. This array with 6 elements, a bracket 4 will return the 5th element. And Numpy array also accepts a negative index. So this index have the same incremental sequence from 0 to -1, -2, and so on. So this is the last one and last element of this array if we use a bracket -1, and this is the first element of this array if we use bracket -6. So a bracket -1, 15 returns a -6, so 10 is returned. To select multiple items at once, you can pass array of index in square brackets. So we can pass an array inside these brackets with 1, 3, 4. Then 3 elements of the array will be returned. The 3 elements 11, 13, 14 of the array are returned. So moving on to the two-dimensional case, they are defined by 2 axes, where axis 0 is represented by the rows and axis 1 is represented by the columns. Thus, index in this case is represented by a pair of values. The first value is the index of the row, and the second is the index of the column. So for example, this is a two-dimensional array with shape 3 by 3. So a bracket 1, 2, we select the element in second row and third column. We create an array first. A, the two-dimensional array, then a bracket 1, 2, so the value element of 15 is returned. Slicing allows you to extract the portions of an array to generate new arrays. So when you use the Python lists to slice arrays, the resulting arrays are copies. So but in Numpy, the arrays are views of the same underlying buffer. So depending on the portion of the array that you want to extract or view, you must use the slice syntax. Such as, you will use a sequence of numbers separated by column within square brackets. For example, this is an array with 6 elements. So if we write A1, 5 in the bracket, then it will return a slice of this array from second to the 5th element. So create an array with 6 elements. Then A1, 5 will return this part of the array. And you can use the third number in the bracket to find a gap in the sequence of the elements. So if we write A bracket 1, 5, 1, 2, this last 2 means the gap of the elements returned. So array will return an array with 11, then 13. So the difference between these two are 2 for this element. So A1, 5, 2, this will return 11 and 13. In the slicing bracket, if you omit the first number, Numpy implicitly interprets this number as 0, That means from the initial element of the array. If you omit the second number, this will be interpreted as maximum index of the array, and if you omit the last number, this will be interpreted as 1 for the gap. So if we do not write the first and second element in the bracket, then it means from the first to the last element of this array with the gap 2, it will return an array with 3 elements 10, 12, 14. Similarly, this will start from the beginning to the 6th element of the array and with a gap 2. Actually, the result is the same as this one, and this will from the beginning to the 5th element but with gap 1. So A column 2, 10, 12, 14, A column 5, column 2, also 10, 12, 14, A column 5, column. So from 10 to 14 returns. And in the case of a two-dimensional array, the slicing syntax still applies, but it is separately defined for the rows and columns with comma. For example, if you want to extract only the first row or the first column, so A is a two-dimensional array, then this will return the first row but all the column of this row, and this will return the first column and all the rows of this column. So A is a two-dimensional array. A 0, comma, column, return the first row of this array. And A column 0, return the first column of this array. And if you want to extract a smaller matrix, you need to explicitly define all intervals with index that define them. So for example, A 0 to 2 and comma 0 to 2, it will return the first 2 row and the first 2 column of this array. So it's a smaller array. And if we want to write, if we write bracket 0 to the first and third row and the first to second column, this part of array will be returned. So we'll see this one, first 2 row, first 2 column, this part of array returned. This is the first and the third row and first 2 column will be returned. Iterating an array, you can use the for constructor to do the iteration of the items in an array. So you can write for I in A, print I. You can write for I in A, print I. But similar as Numpy's for loop in the list, but similar as the for loop for the list. So if you apply the for loop to a matrix, it will always perform a scan according to the first axis is a row. So if we write a for row, A is a two-dimensional array, print a row, then each row of this matrix two-dimensional array will be print out. So we can write for row in A, print row, and row by row, print out. And if you want to make an iteration element by element, you can use the following constructor using the for loop in A.flat. So A.flat will get all elements of this two-dimensional array and put in an one-dimensional array, then print this item out. You can write A.flat for elements. So element by element, each element printed out from this two-dimensional array. And if you want to launch an aggregate function that returns a value calculated for every single column or on every single row, there is an optimal way that leaves it to Numpy to manage the iteration. Can use apply along axis function. So this function takes 3 arguments: the aggregate function, the axis on which to apply the iteration, and the array. So if the option axis equals 0, then iteration evaluates the elements column by column along the column, whereas if axis equals 1, then iteration evaluates the elements row by row. So for example, you can calculate the average values first by column and then by row. So if you write numpy dot apply along axis mean x0 array A, you see how it's going, and if we set axis 1, so we should matrix A first, 3 row, 3 column, then we apply a mean value for axis 0 for this matrix. Mean value 13, 14, 15. Actually, it's along the column. So along the column by column, then we mean value axis equals 1 along the row. And you can also define your own function in using the apply along axis function. So we can define a function called foo and return the value of the parameter. So next we apply this function to array A along axis 1 or along axis 0. Define this function first, then apply along axis for the 1, and apply this function with 0. Actually, the result will be the same because you divide elements by 2 along the row. It's same as you dividing elements by 2 along the column. And the conditions and the Boolean arrays. An alternative way to selectively extract the elements in an array is to use the conditions and the Boolean operators. Suppose you wanted to select all the values that are less than 0.5 in a 4x4 matrix containing random numbers between 0 and 1. So A is a matrix, 2-dimensional array with a random number between 0 and 1. So we can get a Boolean array with same dimension. Then write A less than 0.5. Next, we can use this condition to select elements of this array. So create this array first, random number between 0 and 1, 4x4 dimension, 4x4 the shape, A less than 0.5, it's the same dimension, Boolean matrix. We can select condition. Now it is a 1 dimension with all the values meeting this condition in array A. Shape manipulation. During the creation of a 2-dimensional array, it is possible to convert a 1-dimensional array into a matrix using reshape function. Reshape function returns a new array and can therefore create new objects. So this is 1-dimensional array with 12 elements, and we can write A.reshape to 3x4 2-dimensional array. A is a 1-dimensional array, the random number, 12 random number, and we create another array using reshape to 3x4. We choose this array. Now the dimension is 3x4 2-dimensional array. And you can also use a tuple to modify the shape of an existing array. We can also write A.shape and assign a 2-dimensional array in a tuple. So we assign the shape to A. Then we show A again. Now A is two-dimensional array. And the inverse operation is also possible, such as you can convert a two-dimensional array into a one-dimensional array by using the level function. We use the level function to A, and so A is now is one-dimensional again, and even acting directly on the shape attribute of the array itself, you can also write A shape to 12. You can also first create again A as two-dimensional array. Then we assign the shape to 12, so A is one-dimensional array now. And if you want to transpose a matrix which is inverting the columns with the rows, you can use Numpy's transpose function. We can transpose A. So A's value has been transposed, and now the A's dimension is 4 by 3. So 4 rows, 3 columns now. The join arrays, you can merge multiple arrays to form a new one that contains all of the arrays. Numpy uses the concept of stacking, providing a number of functions in this regard. For example, you can perform vertical stacking with the vstack function, which combines the second array as new rows of the first array. By contrast, the edge stack function performs horizontal stacking, such as the second array is added to the columns of the first array. So A, B are two arrays, both have the shape 3 by 3, so we can vstack AB, then it will be a new array with shape 3 by 6 by 3, and edge stack AB will create a new array with the shape 3 by 6. So A, B, the two array, to A, B, both 3 by 3, then NP vstack AB. So the shape in the new array is 6 by 3. So array B has been added to the rows of the resulting array. And edge stack AB, you see the array A and array B is being stacked, and the dimension is 3 by 6 now. Two other functions performing stacking between multiple arrays, a column stack and a row stack. These functions operate differently than the two previous functions, so generally these functions are used with a one-dimensional array, which are stacked as columns or rows in order to form a new two-dimensional array. So can create 3 array all by one dimension. Then we can use column stack ABC or row stack ABC, row C. So ABC 3 one-dimensional array. Then you can column stack ABC. So they now become a two-dimensional array. The row, each row represents, each column represents these 3 array, and we can also NP row stack ABC. So this also is a 3 by 3 two-dimensional array, and with each row represents ABC. And splitting arrays. To divide an array horizontally or vertically into several parts, you can use Numpy's splitting function hsplit or vsplit. For example, if you want to split the array horizontally, meaning the width of the array is divided into 2 parts. So the 4 by 4 matrix A will be split into 2 4 by 2 matrix. We create A, A is a two-dimensional array, then B and C, these two are the part of the H split A into two parts. You will see A is a two-dimensional array. The shape is 4 by 4. Then B and C is NP H split A2 into two parts. Then we will show B is this part, and C is another part of the matrix A. And instead, if you want to split the array vertically, meaning the height of the array is divided into two parts, the 4 by 4 matrix A will be split into two 2 by 4 matrix. We can write np.v split A2. So this time we use v split. Then we will show B is this part and C is another part of matrix A. A more complex command is the split function, which allows you to split the array into non-symmetrical parts. So passing the array as an argument, you have also to specify the index of the parts to be divided. If you use the option x equals 1, then the index will be columns. If instead the option is axis equals 0, then there will be row index. For example, if you want to divide the matrix into 3 parts, the first of which will include the first column, the second will include the second and the third column, and the third will include the last column. So this we can do this. A1, A2, A3, 3 parts is Numpy split A by column, and 1, 3 are bounded of this separation. So you can see. So A1 is this part, A2 is 2 and 3 column, and A3 is the last column of matrix A. And similarly, you can also do the same thing by row. So this time we can split by the row, with first row and second to third row, then the last row of matrix A. Copies or views of Numpy arrays. If you assign one array A to another array B, you are not copying it. Array B is just another way to call array A. In fact, by changing the element of A, you change the value of B too, and vice versa. So A is an array, then we assign A to B, B equals A. Now if I change the element of A, then B is also changed. Create an array A one, two, three, 4. Then we run B equals A. We should be B is also 1, 2, 3, 4. Now we assign the element, one of the elements in A to 0. Then A will be 1, 2, 0, 4, and B is also 1, 2, 0, 4. So when you slice an array, the object returned is also a view of the original array. So if we create a C, it's a slicing of A, and now we also assign elements, change one of the elements in A to 0, then C is also changed. So C, then C is array 1, 2, and A is array 1, 2, 0, 4. Now we assign the first element of array A to 0. A Now A is 0 to 04. Then we'll choose C. C will be 0 2 because C is the slicing of first and second array element of array A. If you want to generate a complete and a distinct array, use the copy function. So we can use the C is equals A dot copy. So C is another distinct array. If we change some element in A, C will not be changed. C equals A dot 1. Then A 0 C. If we change A to 100, A changed to 100, the C not changed now. Copies or views of Python lists. If you assign one Python list A to another list B, you are not copying it. List B is just another way to view list A. So by changing the element of A, you change the value of B to and vice versa. So A is a list, and we assign A to B. So B and A have the same element, and B is a view of A. So now if we append one element to B, and A change something in A, then both A and B will also be changed and appended. So A is a list. A 1 2 3 4. Then B equals A. B is also a list with the same element as A. Now B append with 5. Then B is 1 2 3 4 5. Then A also 1 2 3 4 5. We also change one element in A to 10. A is now 1 10 3 4 5. Then B also 1 10 3 4 5. And when you slice a Python list, the returned list is a distinct and a new object. So A is 1 2 3 4 list. Then F is a slicing part of A. Then we change element of A to 10. F append 100, and A and F will be changed individually. So A is a list. F is slicing of A. A is 1 2 3 4, and F 1 2 3. Then we change one of the element in A to 10, and we append one element to F. So A 1 10 3 4, and F 1 2 3 100. So they are distinct objects. So when you use a copy to a Python list, the returned list is a distinct and a new object. So A is 1 2 3 4 a list. C is the copy of A. Then we change element in A to 10, and C append 10, and A and C will be changed individually. A is a list. C is a copy of A. A is a list 1 2 3 4, and C also 1 2 3 4. Then change second element in A to 10, and append one element to C. Then A the 1 10 3 4, C the 1 2 3 4 10. So they are independent. Broadcasting of Numpy arrays. Broadcasting allows an operator or a function to act on two or more arrays to operate even if these arrays do not have the same shape. Two arrays can be subjected to broadcasting when all their dimensions are compatible, which means the length of each dimension must be equal or one of them must be equal to 1. If neither of these conditions is met, you get an exception that states that the two arrays are not compatible. So when the rule of compatibility is met, then the size of the smallest array will be extended to the size of the biggest array so that the element-wise function or operator is applicable. So we see an example. A is a two-dimensional array and B is a one-dimensional array. A plus B is compatible and B will be broadcasted to the size of A and then get addition implemented. And broadcasting with the U function, we can demean each column of an array by subtracting the column means. So for example, A is a two-dimensional array with a shape 4 by 3. Then we can write the mean value of this array for each column. So mean 0 means for each column. Then next we can minus this one, minus the mean value of each column from this array. And this matches the broadcasting rules. Next we can also calculate the mean value of each column for this array. So first we show A is two-dimensional array and B is a one-dimensional array. A is two-dimensional, B one dimension. So A plus B will get the same shape with A, and array is a two-dimensional array with shape 4 by 3. You can calculate column mean of this array. 3 value because there are 3 columns. Next, we can calculate the minus array minus the mean of its column. This is the result with the same shape as this array. So this minus is compatible with broadcasting automatically. Next, we can calculate this array's mean value for each column. It will be 0 for each column because it has been demeaned. This value is very close to 0. And if we want to demean each row, the mean vector by row should be reshaped first before doing calculation. So first, we can calculate the mean value for each row, and this is the shape. Then, if we minus this array minus this, the mean value for each row, we have to reshape this value first to 4 by 1. So we will show again this array 4 by 3. Then the row mean for this array, we have to put 1 here. So 4 value because this array has 4 rows. And we can also show the shape of this. Shape is one-dimensional array with 4. If we want to calculate, then we have to reshape this row means to 4, 1. Then it is possible with the broadcasting. So this has the same shape as the original array. And we have to now calculate the mean value for this array. after row mean for this array is 0, very close to 0 because has been demined by row. Okay, using np new axis function to reshape Numpy arrays also. So in the 3-dimensional case, broadcasting over any of the 3 dimensions is only a matter of reshaping the data to be shape compatible. So using reshape is one option, but Numpy arrays offer a special function called np.newAxis along with full slices to insert the new axis. So what this means? We show one array in 2 dimensions, then we can change the shape of this array to 3 dimensions by adding np.newAxis here. Then the shape will be 4, 1, 4. So this array, the 2 dimension, 2 dimension, all the values 0. Then we can create another array based on this array with 3 dimensions. Add np.newAxis here. Then show the shape of this array, now 4, 1, 4. So it has 3 brackets, 3-dimensional array now. And we create another array with random normal distribution for 1 dimension. Then we can change these arrays, can create another array based on this array but the dimension to 3, 1. We can also create another array based on this array but dimension is 1, 2, 3. So this is an array with 1 dimension. But if we run this, it will be a 2-dimensional array with the shape 3, 1. If we will run this, add 1 np.newAxis here. So the shape will be 2 dimension with 1, 3 now. So newAxis will add the shape to this position to 1. Thus, if we had a 3-dimensional array and wanted to demin axis 2, say we would need to write. So this is a 3-dimensional array, and we want to get the mean for 2 is the last dimension. So this mean array will be 2-dimensional because the last axis has been meaned out. And next, if we want to calculate AR minus this mean value, because this mean value is 2-dimensional, so we have to add 1 axis here with 1 dimension, 1. The shape is 1 for the last axis, then it is compatible for calculation. We'll show. So this is a 3-dimensional array. 3-dimensional, 3 brackets, and we get the means and mean out at the last dimension. Sure. So this mean matrix is 2-dimensional with 3, 4. We show the shape 3 by 4. So if we want to calculate the minus, then we have to add np.newAxis here after for this mean matrix. The mean, we can calculate again the mean value for this. The mean is 0 actually. Every value is 0 now. random number generation with the Python random model. So Python defines a set of functions that are used to generate or manipulate random numbers through the random module. Functions in the random module rely on a pseudo-random number generator, function random, which generates a random float number between 0 and 1. So we first import random, then can generate a random number. Import random and generate a random number using random.random. And this number is randomly generated between 0 and 1. Generating a random item can using a choice. The choice is an inbuilt function in the Python random module that returns a random item from a list, tuple, or string. So you import random, and we can print a random value from the list. So this is a list, and can print a random number using random.choice for this list. Put random, then create a list. So list 1 has 1, 2, 3, 4, 5, 6. We use random.choice list 1. This time print the number 4. We can also print a random item from the string. So this is a string, can print random.choice string. String, then randomly choose one alphabet of this string to print out. S, this time is S. And generating random numbers from a specified range and step using random range. So using random range can generate in range from, for example, 20 to 50. The last parameter 3 is the size of a step to skip 3 numbers when selecting. So we can using random.random range 20, 50, 3, then print out. So it's 47. So you can see the 47 minus 20 can be divided by 3. So this number is between 20 to 50 and with step 3 over 20. The seed function is used to save the state of a random function so that it can generate the same random numbers on multiple executions. So for example, we set random.seed to 7, then print a random number, and we set random seed to 5 and print a random number. Then we set again to seed to 7, then this time the number will be the same as this time. We show random seed 7. So we print a random number 0.3323, then set a random number to 5, then print 0.622, then we set to 7 again, then get a random number, same 0.323, and generating random number list in Python using shuffle if you want to change the position of the elements of a choice. So this is the list ABCDE. So we can random.shuffle sample list for this list. So we will see. And print. This is the original list. And random shuffle sample list. We shuffle this list, then print again. So after the first shuffle, now the sequence of elements has been changed. Second shuffle also changed. Sequence. Generating random number list in Python using uniform. This function is used to generate a floating point random number between the numbers mentioned in its argument. So it takes two arguments, lower limit included in generation and upper limit not included in generation. For example, we can use random.uniform to draw a random number between 5 to 10. Uniform 5, 10, 9.54. So random number generation with Numpy's random module. So this time we think about Numpy's random module. The Numpy's random module supplements the built-in Python random with functions for efficiently generating whole arrays of sample values from many kinds of probability distribution. So this is a 4x4 array of samples from the standard normal distribution using normal. So we can run this using random.normal to draw a two-dimensional array with shape 4x4 and the value are standard normally distributed. So import Numpy here. Then we can use Numpy's random module random.normal to a two-dimensional array. Then show this array two-dimensional and the value a standard normally distributed. And we can also draw a 4x4 array of samples from the normal distribution with mean equals 5, standard deviation equals 2. Use np.random.normal 5 to size it 4x4. So this time, this matrix 2x2 two-dimensional Numpy array with the shape 4x4 and the value f normally distributed with mean equals 5, standard deviation equals 2. And set random seed in Numpy. We can return the same random sample. For example, we can set numpy.random.seed to 1, 2, 3, 4, and sample for standard normal distribution with 16 number and shape with 4x4. Then, if we run again, get the same result. Simple. So this time, get this 4x4 ndarray. So if we set seed again to 1, 2, 3, 4, we run this random draw again, we'll get the same result for 471. And you can also use random n to generate a standard normal values. So np.random random n 10. So these 10 numbers also standard normally distributed. You can shuffle an Numpy array with np.random shuffle. So create an array. Okay, print this array 1, 2, 3, 4, 5, 6. And you can shuffle this array. And shuffle this 2, 1, 6, 3, 5, 4. And Numpy is a random permutation method to get the random samples of sequence of permutation. So import Numpy as np, then gfg equals numpy's random.permutation20. See. We show. Actually, it's the 20 number from 0 to 19, then randomly arranged after shuffle. I can get the random sequence permutation of a 2-dimensional array. So create a 2-dimensional array with a shape 4 by 3. Then we shuffle this. This is a 2-dimensional array. This is the original one. And next we shuffle this array. Then the rows, you can see the rows has been randomly reordered. But the elements within each row will not be changed. So reading and writing Numpy array data on files. So loading and saving data in binary files. So Numpy provides a pair of functions called save and load that enable you to save and then later retrieve data stored in binary format. So once you have an array to save, for example, one that contains the results of your data analysis processing, you simply call the save function and specify as an argument the name of the file and the array. The file will automatically be given the .npy extension. So this is a data frame. So this is a Numpy array with shape 4 by 3, 2-dimensional. Then we can save using np.save to save the data, this file with this data Numpy array. We have to import OS package and save the working directory. Then create Numpy array, 2-dimensional array, the shape of 4 by 3. Then we can save this array to this file. Save the data. So you can find this data, save the data. But this is a binary file, you cannot open with txt file. So when you need to recover the data stored in an npy file, you use the load function by specifying the file name as argument. So this time adding the extension npy. So we can also load this file, but have to add npy after the file name. We can load this file to Numpy array. So we show exactly the same as the original array. And the reading files with tabular data using gen from txt function. So you can also read files in textual format, txt or csv. For example, the following data is in the CSV format, so in which data are collected in a tabular format where the values are separated by comma. This file is CSV file. To be able to read your data in a txt file and insert values into an array, Numpy provides a function called gen from txt. So normally, this function takes 3 arguments: the name of the file containing the data, the character that separates the values from each other, in this case is a comma, and whether the data contain column headers. So, because data has a column header, we set true. Delimit the comma and gen from text this file. And we can show this file is a structured array in which the column headings have become the field names. So in the CSV file, the heading become the name of the field. So this is array's value part, and this is dtype part for each column. You can also, the bottom of the array, you can find the column headings contained in the file. These headers can be considered a label, such act as index to extract the value by column. So we can run data ID. We show this array, data 0. We show this array. The data 0. The gen from text function will replace the missing values in the file with an NaN value. So for example, this CSV, the missing value here. If we read this CSV, use the same format, then the second row of this data will have not a number value. We read this file. You can see array, the first row, the second row, the third row both have missing value. We view the column of ID, no missing value. The first row, no missing value. Second row has a missing value. And the reading files with tabular data can also use Numpy's load.txt file. For example, this is a txt file with 6 rows. And when you read text, when you're reading txt files, can have to set the dtype to int, because this is a numerical value, integer value. So we set this to int and read this file, and we print out exactly what we want, a 2-dimensional array with shape 6 by 2. You can also set a skip rows here if you want to skip the first row in this txt file. So this txt file, the index name, but we do not want to read this in the Numpy array. So we skip this first row. I have to set a row, skip rows here. So load text will read from this row first. So this is second row, which means the first row is skipped. And the dtype is string. I have to add str here. Exactly what we want, the 6 by 2 2-dimensional array. So pandas is an open source Python library for highly specialized data analysis. It is currently the reference point that all professionals using the Python language need to study for the statistical purpose of analysis and decision making. Pandas is designed on the basis of the Numpy library, so it is not only makes this library compatible with most other modules, but also takes advantage of the high quality of the Numpy module. Pandas provides two new data structures called series and data frames, which are designed to work with relational data or labeled data, thus allowing you to manage data with features similar to those designed for SQL relational database and Excel spreadsheets. And Pandas provides also an extended set of functions and methods that allow you to perform operations efficiently. Installation of Pandas. And for those who choose to use the Anaconda distribution, managing the installation is very simple. So first you have to see if the Pandas module is installed, and if so, which version. To do this, type the following command from the Anaconda prompt window. We can print conda list pandas, for example. This is the prompt window in Anaconda and in this environment. We can show conda list pandas. So it has been shown that pandas has been installed with the version in this environment. And if you do not have pandas installed, you will need to install and the following command conda install pandas. So if you want to install, just print conda install pandas. Okay. And if you want to start a pandas, the general practice for importing the pandas module in Python session is as follows. So just import pandas as PD and import numpy as NP. So we import pandas as PD and import numpy as NP. This is the standard import. And declaring a series. So to create the series, you simply call the series construct and pass as an argument an array containing the values to be included in it. So we can create a series, use pd.series, then array inside the parentheses. Or we can create an array and manually add the index. So we create an array with this, or create a series with this array. We show this series. The series is a relational data with index, default index from 0 to 3, and the value is the array we input in the creation of a series. So we can also add manually the index string when we creating this series. So this time the index has been changed from A to D. And we can also show the values of a series and index of a series. So we can write s.values. The values is an array with this value, and the index of this series A, B, C, D, the index. And for the data frame, the most common way to create a new data frame is precisely to pass a dict object to the data frame construct. And this dict object contains a key for each column that you want to define, with an array of values for each of them. So if we want to create a data frame, we can create a dictionary first, dictionary with the key, color, key object, and key price. 3 key and 3 arrays are the values for corresponding keys. Next, we can create a data frame using pd.dataframe. Then put this dictionary here. Then it will be a data frame with 3 columns. So show in this dictionary with 3 key value pairs. If we show this dictionary, 3 key value pairs, then create a data frame with this dictionary information. Then we show this data frame. The data frame actually is a tabular data with index. This index default because we have 5 rows. So pandas put the default index from 0 to 4 for these rows. And the column has a header, 3 header variables, exactly the 3 keys in this dictionary. And the values, 3 column values, are 3 values associated with these 3 keys in the dictionary. The series is the object of the pandas library designed to represent one-dimensional data structures, similar to an array but with some additional features. It is composed of 2 arrays associated with each other. The main array, whose data is actually a Numpy array, to which each element is associated with a label contained within the other array called the index. So this is a series. The main array is the value part, and each value associated with an index in an index array. So declaring a series, to create the series, you simply call series constructor and pass as an argument an array containing the values to be included in it. So we can just create a series using pd.series with an array in the parentheses, and the result will be a series. We create this series and show. So this series has value part and index part. So as you can see from the output of the series, on the left there are values in the index, which is a series of labels, and on the right are the corresponding values. If you do not specify any index during the definition of the series, so by default, pandas will assign numerical values increasing from 0 as labels. Often, however, it is preferable to create a series using meaningful labels. In this case, it will be necessary during the constructor call to include the index option and assign an array of strings containing the labels. So we can create a series and manually input an index with 4 strings. Then the result of this string will be like this, and the index has string values the same as we have input here. So we create series with ABCD index. So the index has been the value you want. And if you want to individually see the 2 arrays that make up this series, you can call the 2 attributes of the series as follows: index and values. We can write s.values, and it will show the value part, and s.index to show the index part of this series. So s.values, value part, s.index, the index array. And you can select the internal elements of series. Then select the individual elements as ordinary Numpy arrays by specifying the keys. So we can select, for example, the third value of this series, or we can select by the index string of this value. You can also select multiple items in a series. We select the first two values of this series, and we put up an array inside this bracket. You can choose two values with index B and C. So choose this individual element. The value is 7, and choose the index B. The value is 4 minus 4, and choose the first two values of this index, and choose two values with index B and C. And you can assign values to the elements. So you can select and assign the value of a series by index or by labels. For example, we assign 0 to this series index 1's value. So the result will be like this. You can also assign 1 to this series index B's value. Then the result will be like this. Assign 0 to S1. We show this value has been assigned B to 1. Show again. Then this value has been assigned with 1. And both the series object itself and its index have a name attribute. So if we assign the name attribute of this series as count, and we can also assign the index.name alphabet. So the result will be like this. So the name is a count is for the value part of this array, and alphabet is the name for this index. Assign name, and we assign index's name to alphabet. Then show this series again. See, the main part has a name called count, and index part has a name called alphabet. And you can define a series from Numpy arrays and other series. You can define a new series starting with Numpy arrays or with an existing series. For example, this is a Numpy array, and we can define a series using this Numpy array. The result is the value part is an array. The value is same as this Numpy array, and index is added by default by pandas. We can assign first to create this Numpy array, then create this series using the value of this Numpy array. In the series like this, value part, index part. And we can also define a series from other series. For example, S is a series. You can create another series called S4, and using this series. Can we show four values and with index same as this series. And you can always keep in mind that when you create new series from existing arrays or series, the values contained in the original Numpy array or in the original series are not copied but are passed by the reference. So if the values of either one changes, then values in the other object will also be changed. What this means? So we show this series S and we show this series S4. S4 is created from this series. So if we change S4's last value to 100, we show S4. This value has been changed to S to 100, but if we show S again, S value, this value also been changed to 100. The both series are the reference to one series. So you can filter values of a series. So many operations that are applicable to Numpy arrays are extended to the series. One of these is filtering values contained in the series through conditions. For example, if you need to know which elements in a series are greater than 8, you can write the following statement. PD series, create a series, then we can write S bracket S larger than 8, and the result will be these two values of the series. Create a series with 4 values. Then if we write S bracket S larger than 8, so only this part of the series is returned based on the condition. And some mathematical operations. So other operations such as operators, plus, minus, multiplication and division, and mathematical functions that are applicable to Numpy arrays can also be used to series. So we divide the 2 for this series, divide 2, then each value is being divided, and we can use log function, Numpy's log function for series. This one is not a number. Then we use an exponential function, exponential, and evaluating values. You can check the values of series, including existence of any duplicates and whether a certain value is present in the series. So to know all the values contained in the series, excluding duplicates, you can use the unique function, and the return value is an array containing the unique values in the series. So create a series with duplicate index and values, then can create an array with duplicate values of this series. Use the unique function. So create a series, duplicate value 1, 2, 2, 2. So we use unique function and the value, unique value of this series. And we can also use the value counts to return the unique values and calculate the occurrence of them within a series. So value counts will return each unique value and occurrence of this value. So value counts, unique value and occurrence. And we can also use function isIn to say if the values are contained in the series, and the returned Boolean values can be used to filter data in a series. So if we write series.isIn03, then it will return a Boolean value series. So if true means this value in the series is in these two values, is matched these two values. So next we can use the bracket to filter out the values only meeting this condition. So it will return these two values, only two true here. So if it's in 0, 3, these two are true, others are false, then we can get the values of these true use a bracket condition. So these two value, this part of the series are returned, and not a number value. The specific value, not a number, NaN, is used in pandas data structure to indicate the presence of an empty field or something that's not definable numerically. So pandas allows you to explicitly define not a numbers and add them to a data structure such as series. So we can define a series, and for this value use numpy's NaN. So this is a series with numpy value for this position. Then the is null and not null function are very useful to identify the index without a value, and the returned Boolean values can be used to field values of a series. So if we write is null after this series, then it will return a Boolean value for this series. If it is true, then this value is not a number. Next, we can filter out the not a number value from this series, use a bracket and s2.isNull inside. Create a series with a not a number value, then can use isNull. This value is true, is null value. Then we can filter out this value, get this value. This is not a number. And similarly, we can use not null. So not null, these three are true, and this is false because this is null. And we can also use not null in the bracket to get the values not a value. So S2 not null, so 3 true, 1 false, and filter out the not null value. This is not null value. And series as dictionaries. So an alternative way to think of a series is to think of it as an object dictionary. In fact, you can create a series from a previously defined dictionary. So this is a dictionary with key value pairs, and we can create a series from this dictionary. Then the key will be converted to the index in the series, and the value will be the value in the index in the series. So create this dictionary, then create this series. So the keys of the dictionary transformed as the index of the series. And you can also define the array index separately. In this case, controlling correspondence between the keys of the dictionary and the labels arrays of index will run. If there is a mismatch, pandas will add the not a number value. So we can also using this array as the index in the creation of a series. So because some values in this array does not match the key value in this dictionary, so the index for some of the values in this array but cannot be found in the dictionary will have not a number value. So we define an array called colors and use these colors as the index of the series, but the value part use my dictionary. So the resulting series will have this index matching this colors array, but this value is not a number because green cannot be found in the dictionary. And operations between series. So the labels of series will come into play when we perform operations between two series. So in the following example, we add two series having only some elements in common with the label. Then we get a new series in which only the items with the same label are added. All other labels present in one of the two series are still added to the result but have not a number value. So we create another series called another dictionary called mydict2, and then create another series with this dictionary. Then add this series with this new created series. The result will be like this. So we create a series called mySeries2 with this dictionary. Then we add these two series together. The result will be like this. These four values are not a number because their index only appear in one of the series, not appear in both series. So the value is added, but the value is not a number. Only these two index value added, because these two index red and yellow appear in both series. The data frame is a tabular data structure very similar to a spreadsheet. The data frame consists of an ordered collection of columns, each of which can contain a value of a different type, for example, numeric column, string column, and a Boolean column. The data frame has two index arrays. The first index array associated with length has very similar functions to the index array in series. And each label is associated with odd values in a row. And the second array consists of a series of labels, each associated with a particular column. A data frame may also be understood as a dict of series. So where the keys are the column names and the values are series that will form the columns of the data frame. And furthermore, all elements in each series are mapped according to an array of labels called an index. So this is a typical data frame. So this is the index. So index of a data frame are very similar as index of a series. And this is the column. Column is the color object price are the column names, column headers of the variable, and this part are the values of the data frame. So defining a data frame, the most common way to create a new data frame is to pass a dictionary object to the data frame constructor. So this dict object contains a key for each column that you want to define. So with an array of values for each of them. So for example, this is a dictionary with key, the value, key, value, key, value. So we can create a dictionary based on this dictionary. We can create a data frame based on this dictionary using pd.dataframe, then put this dictionary inside the parentheses. So we can create this dictionary first, then create a data frame using this dictionary. Then we show this data frame. So it has 3 columns and 5 rows. This is the index of the data frame, and pandas added this by default from 0 to 4. So if the dict object from which you want to create a data frame contains more data that you are interested in, you can make a selection. So in the construct of the data frame, you can specify a sequence of columns using the columns option. And the columns will be created in the order of the sequence regardless of how they are contained in the dict object. So we can for example, create a data frame, but with only 2 columns from this dictionary. So create this data frame. We show so only 2 columns in this data frame called frame 2. So if the labels are not explicitly specified in the index array, pandas will automatically assign a numerical sequence starting from 0. Instead, if you want to assign labels to the index of a data frame, you have to use the index option and assign it an array containing the labels. So we can manually add this index when we create this data frame. We can create again this frame 2 with index, and we show this data frame. So now index are from 1, 2, 3, 4, 5. And an alternative way to define a data frame. So instead of using a dict object, you can define 3 arguments in a construct in the following order: a data matrix, an array containing the labels assigned to the index option, and an array containing the names of the columns assigned to the columns option. So we can also create a data frame using pd.dataframe, but inside the parentheses can put a Numpy matrix with the shape 4 by 4. Next, we also add an index array, also add a columns array. We'll create this data frame called data frame 3. Then show this one. So it's a perfect data frame with index and columns headers. Selecting elements of data frames. If you want to know the name of all the columns of a data frame, you can specify the columns attribute on the instance of the data frame object. So for example, we can show the columns of the data frame, and also can show the index of the data frame. We can also show the values of the data frame, use frame.values. So show columns, data frame, columns, this column variable name, and index from 0 to 5. Then the values, value part, 3 column, 5 row. Selecting elements, or if you are interested in selecting only the contents of a column, you can write the name of the column. So we can write a frame, bracket, and quotes price. That will return the value of a price column. Another way to do this is to use the column name as an attribute of the instance of the data frame. We can also write frame.price, frame bracket price. So it will return column value of price. Actually, the returned object is a series. And we can also use this format. Same, result is the same. And we can also use function loc and iloc to select the elements of a data frame. So for rows within a data frame, it is possible to use the loc attribute with the index value of the row that you want to extract. For example, frame.loc2. So it will return this row of the data frame. And if you want to select multiple rows, can specify an array inside the brackets. So inside the brackets, we put 2 number. So these 2 rows will be selected. And we also can select both from row and column. we can select this row and show this one. This row has 3 column variables, and the result will be a series. If we choose 2 rows, it's a data frame, 2 rows and 3 columns, a data frame. You can choose both for rows and a column. So only 2 columns and 2 rows selected. We can also use iLook. So if the selector rows only using integer value, so we can use iLook. So iLook does not support the string column names, only for the numeric value. So for example, here iLook 2 will get the same result as log 2. This also will get the same result as the log 2.4, and this will get the same result as before for the color price for the log selection. Now, if you needed to extract a portion of the data frame, selecting the lines that you want to extract, you can use the reference numbers of the index. The return value is an object data frame. So we can also write column from 0 to 1. Then in this case only 1 line returned, and in this case will return 2 lines. Even if it is 1 line, the result will be a data frame. It's 2 line data frame. And if what you want is to achieve is a single value within a data frame, you first use the name of the column, then the index or the label of the row. So you have to select the column first, then the row. So the result is a single value. We can assign label names to index and columns. So you can assign label names to the array of index and the name of the columns. For example, this is a data frame with 3 columns and with 5 values, 5 rows. Then we can assign an index name called ID using frame.index.name, and can also assign a name called item to the columns using frame.columns.name. So we create data frame first. Three columns, 5 rows. Then we assign ID to the index name and assign item to the columns name. We'll show this data frame again. So now you can see ID appears here, an item stay here. Item is the name of this column. ID is the name of this index. Add a new column. And you can do this by simply assigning a value to the instance of the data frame and specifying a new column name. For example, if we write frame brackets new equals 12, then for this column, this is a new column created. Then all rows for this column has value 12. And if we assign this array to this column, also possible. So frame new equals 12. So we show this data frame again. You see this new column, all the rows have same value 12. And if we assign a new column with this array, value now is the array assigned. And the columns of the data frame can also be created by assigning a series to one of them. So for example, this is a series with number from 0 to 4. Then we can create a new column to this data frame, and the value is the series value. So this is a series value 0 to 4, and we can assign this series to the column new of the data frame. Show again. So now data frames, this column's value is 0 to 4. And to change a single value, you simply select the item and give it the new value. For example, if we want to change the value of the column price, and this is the third value, third row of column price to 3.3, we can just write the frame bracket price, then bracket 2 equals 3.3. This is a warning message. Show 3.3 this value. And the membership of a value, you have already seen in the previous lectures that the isIn function can be applied to the series to determine the membership of a set of values. And this feature is also applicable to data frame object. So we can write data frame dot isIn, and inside the parentheses is an array for these two values. So we can learn the data frame is in these two values. So you can see some appears true. So if the value equals either this one or this one, it will be true. Otherwise, it will be false. And you get a data frame containing Boolean values, where true indicates values that meet the membership. If you pass the value returned as a condition, then you will get a new data frame containing only the values that satisfy the condition. So we can use this condition inside the bracket, so the data frame will only return the values of these three values, the other will be not a number. And deleting a column, so if you want to delete an entire column and all its contents, use the delete method, del command. So we can write del frame new, then this column will be deleted. Delete frame new. Then we show this data frame again. So no column called new now, only 3 columns left. And the filtering, you can apply the filtering through the application of certain conditions. For example, say you want to get all values smaller than 1.2. The elements not matching the condition will be replaced with not a number. For example, this is a data frame. Then we can add a condition with bracket after this data frame. And the condition is if data frame less than 1.2. We can create a data frame first. So this data frame has 3 price columns, 5 rows. So we can run. So only these values less than 1.2, other values will be not a number. The data frame from nested dictionary. So a very common data structure used in Python is a nested dictionary, as shown here. called nest dict, and this is the external key, a key, red, white, blue. Then the value for the key is also a dictionary with key value pairs inside. So we can create a data frame using the information of this nest dictionary. So this data structure, when it is passed directly as an argument to the data frame constructor, will be interpreted by pandas to treat external keys as column names and internal keys as labels for index. So red, white, blue are external key of this data object or library dictionary. Then this value will be converted as column names in the resulting data frame. And internal keys like 2012, 2013 will be the index of the data frame. So we create this nested dictionary first, then create this data frame using this nested dictionary. Show this data frame. You can see now the red, white, blue are the columns, and the 2012, 13, 11 are the index. And it's also possible that not all fields will find a successful match. Pandas compensates for this inconsistency by adding NaN. You can see this not a value. And the transposition of a data frame. You can get the transposition of the data frame by adding the T attribute to its application. So you create a data frame, then transpose. We create a data frame called frame3 with color. Color is index and columns are object, ball, pen, pencil, paper. Then if we transpose this data frame, then the color will be the column and objects are indexed now. The index objects in pandas series and data frame are responsible for the labels on the axis and other metadata as the name of the axis. So we create a series with this value and with this index array. So if we write serial.index, it will show the index. Create this series first. Then can show the index of this series. And unlike all the other elements in the pandas data structures, the index objects are immutable. So once declared, they cannot be changed. This ensures the secure sharing between the various data structures. Methods on index. So there are some specific methods for index available to get some information about index from a data structure. For example, ID minimum and ID maximum are two functions that return respectively the index with the lowest value and the index with the highest value. So in this maximum is blue, a minimum is blue, then maximum is white. Arranged alphabetically. And index with duplicate labels. So far, you have met all cases in which indexes within a single data structure have a unique label. Although many functions require this condition to run, this condition is not mandatory on the data structures of pandas. For example, see a series with some duplicate label. We create a series with 6 values. An index array. You can see white, white, green, green, duplicate. So regarding the selection of elements in a data structure, if there are more values in correspondence of the same label, you will get a series in place of a single element. So if we want to show the value of this series with the white index, then it will return two values in a series. And the same logic applies to the data frame. With duplicate index that will return the data frame. To create a series with duplicate labels in index, then we show the index to the values of index with white to return two rows, and the result is a series. And the pandas provides is unique attribute belonging to the index objects to tell if they are indexed with duplicate labels inside the structured data, both for series and data frame. So if we write series.index is unique or frame.index is unique, series.index is unique, false, because there are several duplicate index in this series, and we create a data frame also. Data frame has 3 columns, 5 rows, index from 0 to 4, and we show this data frame's index is unique. Yes, true, because index no duplicate values. Reindex. It was previously stated that once it's declared in a data structure, the index object cannot be changed. But by executing a reindexing, you can also overcome this problem. It is possible to obtain a new data structure from an existing one, where indexing rules can be defined again. For example, we create a series with 4 values, and this is the index string for these 4 values. And during reindexing, it is possible to change the order of the sequence of index, delete some of them, or add new ones. So in the case of a new label, pandas adds not a number as the corresponding value. So for example, we can create a new series using reindexing. So serial reindexing with these 4 index strings, then the result will look like this. 3, 4, 5, 3, 4, 1 has value, but 5, the value is not a number, because in this series, no index value equals 5. Create a series with 1, 2, 3, 4 index. Then reindexing with the index value 3, 4, 5, 1. Then the result is another index, but 5 index value is 5, since value is not a number. And you can also use reindexing with interpolation. So we create a series with 4 values, and this is the index. Then can write reindexing range 6. Range 6 is from 0 to 5. The method ffill forward filling. Then the result will look like this. From 0 to 5 indexing. Then the value comes from series 3, but if not available value, for example, index 2, 4, not appear in this series, then these 2 values will be filled forward filling from other values. And similarly, if we set method bfill backward fill, then if the index cannot be found in this series, the value will be filled backward. we create a series first with 4 values with these 4 index. Then we re-index this series and with expected index from 0 to 5 in the new series, and using forward fill method. And this is the resulting series. And if we use backward filling, then if the value cannot be found in this series, will be backward filling from other values. And we extending the concepts of reindexing with series to the data frame case. You can have a rearrangement not only for index but also with regard to the column. So this is data frame, then reindexing this data frame, and we'll return a new data frame with the range index with the range from 0 to 4. And the method is forward filling, and a column is these 4 columns. This is the result data frame. So we show the frame again. First, this is the data frame. Then we use reindex of this data frame with index from 0 to 4, method forward filling, columns, colors plus news objects. Then this is the resulting data frame. And if we use backward filling, so this column new will be filled with the neighboring column's value, backward filling, and in this case it will be forward filling by the neighboring column's value. You can see this column the same as this one, and if we use backward filling, this column are the same as this one, because the original data frame has a new column called new. And a job for series, this method will return a new object and without the items that you want to delete. We create a series first with this index, and the value is 0 to 3. Then next we can job yellow index. Then the result will be a series with 3 rows, 3 items. We can also job this blue and white both. Create a series, 4 values with this index. Then we job yellow, then return another series without the yellow index. We can also draw 2 values, then only return this red and yellow. And job used for data frames. So regarding the data frame, instead the values can be deleted by referring to the labels of both axes. So this is a data frame with index column, 4 columns for index. And if we want to delete rows, you just pass the index of the rows. The frame.job pass these 2, then these 2 rows will be jobbed. And if you want to delete columns, you have to specify axis equals 1 here. So we create a data frame, 4 columns, 4 rows with this different color index. Then we job blue and yellow. And the result will be a smaller data frame with 4 columns and 2 rows. And if we drop pen and pencil at axis equals 1, then the result will be a data frame with only 2 columns, and the pen or pencil columns are dropped. Arithmetic operations and data alignment. The pandas can align indexes coming from 2 different data structures when you are performing an arithmetic operation. For example, 2 series are defined, but the labels of them are not perfectly matching each other. If summing these 2 series, so when the labels are present in both operators, their values will be added, while in the opposite case, they will also be shown in the result in the new series, but with the value not a number. So we create 2 series, but with not exactly the same labels in the index. So if we add these series together, some labels which do not appear in both series will have a value not a number. So create these 2 series. So S1, 2, 3, 4 values, 4 labels. S2, 5 values, 5 labels. Then we sum this series. Result will look like this: 1, 2, 3, 4, 5, 7, 5, 6 labels, 6 value, but 3 of these values are not a number, NaN value. In the case of the data frame, although it may appear more complex, but the alignment follows the same principle as in series, but is carried out both for the rows and for the columns. So we create 2 data frames, then sum these 2 together. The result will like this, many not a number value. We create 2 data frames. Let's show data frame 1 and data frame 2. 4 columns, 4 rows in the data frame 1. 3 columns, 3 rows, the data frame 2. Columns not the same. Pen has pen, ball, but pencil, paper, mark only appear in one data frame. Then we sum these 2. That will be a 5 column, 5 rows data frame with many. For these 3 column is not a number value, and these 2 rows, green, red, also not a number value. And this is called flexible arithmetic methods. So for example, we can use frame 1 dot add frame 2, the same as frame 1 plus frame 2. Can use this example. Result is the same as before. And operations between data frame and a series. For example, we define these 2 structures, and the index of series match the names of the columns of the data frame. So this is a data frame with columns ball, pen, pencil, paper, and this is a series index also ball, pen, pencil, paper. So if we use minus the series from this data frame, the result will be like this. To create data frame first, 4 columns, 4 rows, then create this series, index same as the data frame's column, then minus, result like this. As you can see, the elements of the series are subtracted from the values of the data frame corresponding to the same index on the column. The value is subtracted for all values of the column regardless of their index. So the whole column has been minused with this series value for the ball, and pen column, all the rows value has been minused with series value of pen. And if an index is not present in one of the two data structures, the result will be a new column with that index only, such all its elements will be not a number. So for example, we set series mark equals 9. Then if we minus frame with series, then the result will have 4 rows but 5 columns. One column mark comes from this series and with all the value not a number now, because this mark does not appear in the data frames column. We create the new value in the series. So now series has a label mark and the value is 9. Then frame minus series, the results, the extra column for mark but not value are all not a number. And function application and mapping functions by element. The pandas library is built on the foundations of Numpy and then extends many of its features by adapting them to new data structures as a series and a data frame. So among these are the universal functions called ufunc, and this class of functions operates by element in the data structure. For example, you could calculate the square root of each value in the data frame using the numpy's np.squared. You can write np.square root, then apply to this data frame. So data frame created. For columns or a numerical value, then square root this data frame. We return another data frame, same column and the same row, and the value are square root of the corresponding data frame's value. And functions by row or column, using the apply function to apply, for example, and the user define a function on columns or rows of the data frame. So we can define a function called fx and to return the maximum value minus the minimum value. So if we apply this function to the data frame, then the result will be a series, and the labels, index labels, are columns names of the data frame. So this function will be applied on each columns of the data frame. Define function. We can also define function like this way. This is another way, lambda, but we use this way also. Then data frame, apply this function, return a series. The labels are columns of the data frame, and the value are a difference between maximum value and minimum value for each column of the data frame. And if we want to apply by rows, we can set axis equals 1 in the apply function. So this data frame also apply this function, but by row, set axis equals 1. The result will be the series, the labels at the rows of the data frame, and the values are the difference between the maximum value and the minimum value for this row in the data frame. Extending the application to many functions simultaneously, the result will return a data frame. So for example, we want to return the the minimum and maximum value, two value, and index called minimum maximum of this series in the definition of this function. Then we apply this function to data frame. Then the result will be a data frame with this index name, and each row represent the minimum or maximum value of this column of the data frame. We define this function which will return a series with two indexes. Then apply this function to the data frame. The result is a data frame, minimum value or maximum value of each column of this data frame. Most of the statistical functions for Numpy arrays are still valid for pandas data frame, so using the apply function is no longer necessary. For example, functions such as sum and mean can calculate the sum and the average respectively of the elements contained within a data frame. So we create a data frame with 4 columns and with 4 index labels. Then we can just write frame.sum. Then the result will be a series, and the index labels are column names of the data frame, and the values are the sum value of each column of the data frame. Create data frame first. For columns, for rows, then frame.sum return a series, the sum value of each column of data frame. And if we want to get the sum of each row of data frame, we have to add axis equals 1 here. And we can also calculate the mean value of each column of the data frame. Sum of the row. So the result is a series with the index labels are color, and index of the data frame value are sum value for each row, and can get the mean value of the data frames each column. Also is a series. We can calculate accumulation of each column and the row, for example. So this is the accumulation value for each column. Use frame.cum, and if you want to calculate the accumulation value for each row, then have to add axis equals 1 here. So the accumulation value for each column of the data frame. So each row by row calculated, accumulated. Then the accumulation of each column, each row, we have to add axis equals 1 here. Then for each row, accumulate the value. Accumulate the value. And describe function allows you to obtain summary statistics for the column in this case. So it will show the count, mean, standard deviation, minimum, and percentile value, quantile value, and maximum value. So frame.describe. So each column's statistics, descriptive statistics are calculated. And correlation and covariance between two series. So this is two series with same labels. Then we can write SEQ, the first series dot correlate the second one, and the result is the correlation of